Welcome back, everyone. We are here for day 7 of the Go Cloud Careers completely free certified cloud security professional bootcamp. In case you're just joining us for the first time, my name is Michael Gibbs. I'm the CEO of Go Cloud Careers. And if you just joined us, you can go back and see the first 6 days. They're on our YouTube channel. So my team will drop a link to that playlist. So all these days, you can join us now. Go back and see other sections on other topics later. So welcome, everyone. So I am joined here by our Chief Technology Officer, Mark Milovanovic, and together we're here teaching this course, answering your question. We both put in a lot of time, along with other members of our team, to put this training together for you. So I hope you're enjoying it. Letting you know that our team wrote a book for you to help you pass this exam, and it corresponds exactly with the order we're doing this. So if you haven't grabbed the free ebook for the Certified Cloud Security Professional exam, go download it. It's completely free. And now I'm gonna I'll turn it over to I'll talk about one more thing. On tomorrow night we have right after we're done, we're gonna have a session on Zoom where we'll answer any questions you have. We're doing it on Zoom so we can have a face-to-face conversation, because you may have a question and then we're going to need more information, so then we can answer your question, and we'll need more information. So it's there, it's free. Ask us about any kind of technology careers you want, as long as it's related to networking or security or anything in cloud computing. Mark and I can definitely help you. Anything out of, say, software development. We're really happy to guide you. We're happy to do this, and we're happy to have fun with it. So that's tomorrow night. And on Thursday, we have our completely free webinar on how to become a cloud architect. But whether you want to become a cloud architect, an enterprise architect, an AI architect, many of these tenets are the same. Come join us on this webinar. And here's the reality. I'll answer questions on any of these architecture careers. So join us. It's completely free. So nice to have you. Let me turn over to Mark. Mark will tell you where we are at in your document and talk about all the background and, more important, and super technical things related to this course.
Yeah. I mean, I'll be honest with you, everybody. I can't even believe we're at day 7. I mean, time flies. I mean, even though we covered some of that software development life cycle, a little bit more of the, can I get away with saying this on live stream? It was a little boring, the life cycle of software development. Not trying to offend anyone, but there's exciting stuff that we're going to go through. Like today, we're going to cover a bit more of the virtualization concepts. That also includes how we're going to manage these type of what we call hypervisors, basically the virtual machine managers. We're going to look at some additional storage options, and we're also going to look at some data resilience. And then everybody's most exciting topic, and I don't mean this in a degrading way, but incident management, which is really important when it comes to security. So we have a lot of fun stuff. If you've not downloaded the free study guide, we have a link in the description box below this video where you can download it from. Or to make it a little bit more convenient for everybody, take a look at the chat box as well. Our team has dropped the link in there for the study guide, for our Q&A session that we're going to have tomorrow, as Mike mentioned, a little bit after this bootcamp, a little bit after 5 p.m. Eastern Standard Time. And if looking at that study guide, if you want to follow along, since it is a complimentary piece of material that you can use it as a slide deck. I invite you to turn your attention to page 261, because that's what we're going to pick up. Aside from that, there's a lot of fantastic goodies as I look at our description box. If you want to learn a little bit more about what the cloud architect career entails, we got a free ebook that you can download. You can read a little bit. Perhaps you can kind of use that to gauge some questions you might have for Thursday's webinar. Get a little bit prepared, get into the mindset of an architect when he does a little bit of his reconnaissance or his discovery work when trying to figure out what type of things he might need to address. Additionally, we got, if you take a little further look down there, we got also CCNA Bootcamp that we did a little bit while ago. If you're interested in learning a little bit more about networking, that's going to be a fantastic thing. And if cloud technology is something that you want to get a little bit more familiar with, we also have a link in the description box when it comes to an AWS professional, I believe it is, solution architect video course that you can take a look, enjoy it. It's hours upon hours of information that you can ingest, digest, and take with you and have some practical application. To start us off, everybody, I want to let you know we are from Florida in the United States. Please let us know in the chat box where you're from. We're always thrilled to see such an international community. We hope we have one today too. And feel free to put in our Keep Alive message. That's my little tech bit for right now as we start off, just to make sure that everybody's present, put a hashtag CCSP into the chat box as well. Aside from that, uh, the most important thing that I want everybody to do right now is have fun. Because if things are fun, your creativity is going to go up. You're going to start thinking about questions. How do I apply to you the content that we're going to cover, or just generally some ideas you're going to have that you need some clarification on. So have fun with today's session, and I'm going to turn it over to Mike, who's going to get us started on tenant partitioning when it comes to the data center.
Sounds great. So nice to be back with you. I love how we have people everywhere from Jersey City to Sacramento, Argentina, Melbourne, Kenya. Absolutely love that. I'm pretty sure we have some people in other parts of the world too. And I always love this. And I'm in South Florida today. Now, we're going to talk about tenant partitioning in shared data centers. So let me describe the context of this shared data center. So we have what's called co-location spaces, and many of them are shared data centers. And what happens is you go to these buildings, the buildings have power, they typically have networking built in place, and you put your own racks potentially in a cage, and you put your own servers on the racks. So all of your stuff in your racks is yours, and it's secure. And in your racks, you can place a router that can contain your wide area network that would go back to your data center and cloud that is completely secure and separated from everyone else. And then what you could do is you could use you can use their providers' internet connections, and you can put a firewall between you and the rest of the users in the internet if you needed to. And you could create any kind of demilitarized zones or whatever you would need in these types of environments. But it's a shared data center. But if you maintain separate networks, and these networks don't need to talk to each other or necessarily be connected to each other, they only need to be connected to the internet, and the servers are separate, the only thing they're really in is the same building. And this is one type of can be done. Shared data centers could also have, this is your room, and this is somebody else's room, and this is somebody else's room, and you put your stuff in your room. But that's typically what we're talking about when we talk about co-location providers or shared data centers. And they can be fairly secure. Additionally, in these shared data centers, which are basically renting space in a pre-made data center that's made for you because it's got the power there, it's got the cooling there, it's got access to a lot of easy wide area connection networks and lots of fiber under the ground, those types of things. So in these environments, you might still want to input your own cameras because it's a shared data center. And even though your cages are locked, you might want cameras to make sure people aren't coming into your systems. And potentially in a shared data center, you may need someone from the company to actually fix something in your rack. And in that particular case, some of these shared data centers offer remote hands where they would have access to a key to get into your cage, to power cycle a server, replace a card on the server or a hard drive on the server if they needed to. So you might want to have cameras for that too. So just thinking about that because it's shared. Now, in a shared data center, let's talk about access control. It needs to be, generally speaking, more secure than a single data center because it's a much higher value target to walk into a building and get lots of customers' information than it is for a single customer. So there needs to be good, strong physical security, multiple methods, locked cages, locked doors, locked racks, locked everything, maybe fences, potentially dogs. Lots of high-end security going in and out of these things are going to be necessary. Now that's at the physical level. At the logical level, there need to be controls for the console, or whether you have like a KVM access, or whether you have direct server hardware access. So this kind of environment is going to need some very good access controls. You're going to have some good logging and monitoring. Then again, you should have that everywhere to really make sure you're getting no unauthorized access. And in these environments, you really need to place an emphasis on provisioning and monitoring, maintaining access. Let's briefly talk about what you call virtualization operations. So remember the cloud, the public cloud, the private cloud. It's just a data center. Now, the public cloud is somebody else's data center that you run space in, and in your own environment, it's just a data center running cloud software. Now, for the last 20 years or so, actually since 1999 when VMware came out with the x86 hypervisor, all these data centers have been, for the most part, virtualized. And they've done it for lots of reasons, more power efficiency from the server. because instead of buying a server that has 4 cores and using it for a single application and having it use, say, 250 watts, I can buy one server that might use 1,000 watts that can have say 384 cores in there, and I could have 30 or 40 or even 50 small servers, or even 50 moderate sized servers inside of that single server. So if you think about that, for the most part, one big server, it may cost a little more for the server and a little more for the CPUs and a little more for the DRAM, but power, space, and cooling efficiency. So that's why all data centers have kind of been virtualized for the last 20 some years. And the cloud providers are nothing different. They just have their own hypervisor and their own virtualization software. In a data center, you might have VMware or vSphere. The cloud providers just made their own equivalent of something like that. Basically all the same thing. Now, we have to understand lots of things that we like about virtualization is you can schedule things and have them push out to lots of systems at the same time. The ability to take a server as a single file that can move from one server to another. The ability to pick up and move things. For example, you may have a server, the server itself may have a hardware issue. You can take that virtual machine off of the server with the hardware issue, move it over to a different server directly over the network, run it from the good server, and then do the maintenance on the server that might need some DRAM replaced or a power supply replaced or a hard drive replaced. So virtualization makes it easy to move, add, change. So it's there. And keep that in the back of your mind. Now, when it comes to virtualization, there's this concept of a dynamic optimization. And what are we really talking about? We're talking about assessing the performance and other factors of what's going on and being able to see it and being able to look at the utilization and look at the leftover capacity and be able to take actions and make decisions fairly quickly. And it makes it pretty easy for us to do this in a virtualized environment. It's much harder managing a whole bunch of single servers on the hardware than it is managing a virtualization environment that can give us a map of where our virtual machines are and what's going on with those virtual machines and the performance of each virtual machine, CPU, DRAM, storage, all of it. So it makes it very easy, specifically in maintenance things. Now, virtualization typically makes it easier to deliver high availability, and it makes it easier because we're going to be in an environment where instead of having it in one or two servers, we can have virtual machines inactive in other servers if we really wanted that can have access to all the data or even it's synchronized and barely utilized, but we can use more of them. And it's easier to move them, add them, change them, copy them. And by having more systems that we can load share across and the simplicity of bringing up systems and down systems when we need them, we can create higher availability environments that are less dependent on specific hardware. And that's really where we've been here from an availability perspective. Now, virtualization could be virtual machines like we showed you on the first day, where we took you into our Go Cloud Careers data center and we showed a VMware server to you, and then we created a virtual machine or a couple of virtual machines on that server. We've done that together. We also could be using containers, and we talked about, and I whiteboarded out how containers actually occur, how we're basically virtualizing the operating system, if you will, on the server. And then each container basically runs independently and separated from each other through a logical virtualization. And each container really only contains the application's dependencies, because the applications are pulling libraries from the underlying operating system. So we did discuss that to an environment, but realistically speaking, how we talked about with virtualization, where each one has its own operating system, we don't have to worry about that with containers. So we talked about earlier that it being very lightweight. Now, if we have these containers, if we've got these lightweight applications, we need to kind of figure out what we have. So we need to maintain a container registry. We need to make sure we can secure the images of these containers, make sure they're patched, and make sure they're in an environment that they can't be modified until we want to use them. Now, under the concept of virtualization, I kind of want to discuss what's called ephemeral computing. And ephemeral computing is really just using a bunch of compute capacity for a short period of time because you need it. And then when you're done, returning that compute capacity back to a pool. So let's talk about examples where you might want to use that kind of ephemeral computing. Let's say an organization has a tremendous amount of data that they need to mine through 1 day per week. And the rest of the time, they don't need a lot. Well, maybe what that organization can do is run their data in their data center all week and then shoot that data straight over to the cloud, pick up some unused compute capacity, the equivalent of an AWS spot instance, or what does it, Google call it, a preemptible instance, same kind of thing. Use some of these spot tech capacity or this excess capacity, run your batch job, do your analysis, bring your data back. And that way you've got the benefits of your data center and you leverage the availability, agility, and scalability of the cloud. Those types of environments. So thermal computing is big in cloud computing. The ability to just spin up resources, use them for as long as you need them, and then no more, and just shut them down. Now, we talked about it before, this concept of serverless technology, and I will make it very clear there's no such thing as serverless. It's a silly made-up marketing name. Here's what serverless really is. I, the provider, create an application hosting environment where you basically just upload your code. And your code runs on the cloud provider servers, and we don't tell you where it runs. So you have no control of where it's running, no control of anything that's done on the back end, and it's all just done on the back end for you. You don't have to think about it. So that's serverless, but it still runs on servers. There's no magical thing flying through the clouds or just dancing through the air that's doing the calculation. It runs on the same servers that we've always used. Now, because we're actually dealing with virtualized data centers, either in our private clouds or the public clouds, somebody has to deal with the hypervisors themselves. You'll recall that hypervisor from the previous days where we drew out the hypervisor is what separates all those virtual machines on the server, that manages the server's memory, CPU utilization, and scheduling, that schedules how the utilization of the drives are in that server, for example. What happens if somebody hacks that hypervisor? Can they escape from one virtual machine to another virtual machine? Can that mean one virtual machine can hack another virtual machine on that thing? Now, in the cloud, for example, you could have you and 50 other customers all on the same server, or maybe 100 customers on the same server. If you can escape one virtual machine to another, you got a big problem. So there's the concept of a hypervisor, which is a target for attack. So in any data center, and of course the cloud providers do this too, they're constantly patching whenever they have to do their hypervisors, their management planes, their control planes, but make sure these things are done. Otherwise, you can get security breaches. So we really have to think about that focus of these underlying infrastructures, configure them, make sure they're configured properly and locked down, make sure they're updated, make sure they're patched, use, relatively speaking, industry best practices whenever possible. On your hypervisors, restrict or suspend user accounts, because this is a dangerous place for people to have access. Require multi-factor authentication, use logging, alerting, monitoring, really keep track of who's doing what. Make sure only authorized users can access this system, and then make sure you don't give access to this to absolutely everything. For your virtual machines and the data, encrypt them so that they can't be accessed without the decryption key. Make sure you're using a secure boot for the underlying hardware so it goes to where you want it to actually go and it checks whatever it needs to. And anytime you've got a data center, you really want to audit the configurations of your systems. And honestly, anytime you're in the cloud, you want to audit the configurations of your systems to make sure they didn't drift off of where you wanted them to be. The secure golden image, golden build, if you will. So if you'll recall with the hypervisors, we had a logical isolation of our virtual machine, which is great. So we have to make sure that we take care of everything. Each virtual machine really needs to be isolated from each other's. On our virtual machine, we should make sure that we should make sure what they have access to. Maybe our virtual machines need to be hardened as well. And they should be host-based firewalls, host-based IDS, IPS systems, security type groups, all of it. Disable unnecessary services. Let's talk a little bit about storage operations. So, in our cloud computing environment and in our data center, we're going to have a lot of storage. So, in cloud data centers, we remember are virtualized environments. So, they're going to have access to all kinds of storage, near term storage, long term storage. Now, when we're dealing with the cloud provider, they have concepts of storage clusters. And basically, what's going on here is they have machines with a whole bunch of hard drives and they offer virtualized services to you. And they've got a fairly tightly coupled architecture to the backplane of this network. They've got big, powerful network cards. They're plugged into the IP network. Typically speaking, the machines have access to these things, and that's how they're pulling our data. But I think now is probably a good time to pause for a few minutes, especially if there's questions on that storage, because I'm trying to convert academic storage into what the way they describe it into something that makes sense, and I'm not sure that I did the best job there. So if I confused some people there, Mark and I will clear that up.
So which page are we on in the resource? It should be page 268. So what you want to be looking for is the heading that says storage clusters loosely coupled architecture. That's kind of like where we stopped, and then we'll eventually pick up and we'll start looking at resilience and high availability when it comes to storage. So but right now 268. So a question from Kennedy, he's wondering, in a cloud computing system, how do we hedge against fileless attacks? So, Kennedy, what you're specifically describing here is an attack that doesn't rely necessarily on, let's say, physical service in the sense that it tries to find vulnerabilities within this, but you're looking at attacks that are going to be running predominantly in something like as ephemeral like memory, right? Something that's there for a moment and then eventually can go away. Unfortunately, for the bad guy, not for us. Unfortunately for the bad guy, even though this is a pretty sophisticated attack that they're going to have against you and your organization, there are things that we can do. One of them is going to be to have some type of scanning tool, something that also understands to do a behavioral analysis. That way it can actually look through the memory and take a look if it can detect any kind of suspicious activity. This is actually even pretty common in endpoint detection and response systems, even like the ones that you have on your personal computer. So we definitely have some very robust options when it comes to endpoint detection for servers and of course of our work computers. Additionally, what you should be doing is, since these attacks are going to be trying to run in memory and then eventually trying to attack application and some type of vulnerability, it'd be really good to make sure that within whatever security systems you do use and the ones that are going to be monitoring and analyzing it, that you have what we call a whitelisting of applications that should be executed and ran, and also some blacklists. So whitelist, you can think of things that are permitted to run, and then blacklist is something that you don't want to be running. So those are some important things you can do. And then of course, as practitioners, it's always very important. You want to make sure that your systems are regularly updated. You want to make sure that they're patched. That way that there is no obvious vulnerabilities. And again, we're not going to go into what that all entails. That's mostly like a system administration kind of job. But you definitely want to work with a system admin and making sure that all the systems are patched accordingly, and also test it before security updates and so forth are actually run. Otherwise, we might get into a potential where we might be bricking or kind of ruining our systems unnecessarily because of how code is executed there. And then lastly, you always want to make sure that you utilize access control. You know, think of it that we haven't discussed it in detail, as something like zero trust networking, where you want to have least privilege. You always want to not trust anyone that's going to be accessing any of your applications or tools that you have on your network. So you want to have really stringent access controls in what is allowed to be accessed and by whom. And if you can go as far as implementing something as a framework like zero trust, there's always going to be that idea of also not just authenticating always, you're also going to be authorizing, and you're also going to create segmentation where you're subdividing where and what a person can do. And then again, there's going to be continuously monitoring what is happening there. And if case there's something we don't like, guess what? We can decrease what we call the trust core, meaning what we believe that this endpoint should be capable of doing, and also kind of gauge or stage back kind of like what we would be allowing them to do. So that's quite a little bit of an exhaustive list, but when we're dealing with something as sophisticated as a fileless type of attack that can run within memory, we definitely need to take a holistic defense in depth type of approach where we have multiple layers of security in case something slips through, that we still have other avenues of protecting ourselves and our organizations from such an attack. And the next question is, what is the difference between storage area network and network area storage, or network attached storage?
Yeah.
Right.
So in this particular case, there really isn't a lot of difference, but here's the main difference. A storage area network is typically block storage, whereas network attached storage is typically file storage. Now, how silly is this actually? Both of these systems have a whole bunch of hard drives them in an array. And it's just typically the way the data is actually stored on them. So block storage, storage area network, file storage, network attached storage. But they're both can be sitting on the same IP network at this point. So that's why you can almost think of them all block storage, object storage, file storage, as storage area that networks, even though they're not technically, if that makes any sense.
Yeah. And guess what? As a security architect, you don't have to worry so much about the performance when it comes to all these things, but there are performance differences. Something that probably would be worthwhile paying attention to. And again, we're not going to go into the weeds of this now, but from a security perspective, the protocols that you would be running either on a storage attached network or network attached storage, they could vary. So for example, if you're using, let's say, a storage attached network, you might be running something like fiber channel or fiber channel over Ethernet. So it might be worthwhile checking into how you can secure that type of protocol. Compared to something like a network attached storage, you might be running something like the network file system. You might want to look into what are some common best practices to secure that. The CSSP doesn't necessarily call this out, but again, give you a little bit real world application. When we think about protocols, it's not just always the hardware, but also the logical aspects of the solution that we have. So security perspective, pay attention to the protocols that are being in play and see what we can reasonably do that is also financially viable in securing those pieces of the infrastructure. Okay. Very good questions, everybody. Keep them up. They're wonderful questions. We look forward to seeing what else everybody has in mind. If you're enjoying so far what we're presenting here, please give the video a like. And I'm going to turn it back over to Mike as we go on considering further more content.
All right, so let's have some fun with it. Now let's talk about RAID, or redundant array of inexpensive disks. And it's something we can use to add some resiliency to our data in the cloud. It's something we can do to improve our resiliency in the data center. So let's kind of talk a little bit about what that actually is. And let me just architecturally map this one out for you. So many of you are familiar with load balancers, and RAID is honestly like storage load balancing. And I'll show you what I mean. So RAID is going to take when we take more than one type of a drive disk and we put it together. Oops, I don't know what just happened there. So in this particular case, we've got two hard drives. This is going to be hard drive 1. This is going to be hard drive 2. And for argument's sake, it's a small drive. It's 2 terabytes. The other one is 2 terabytes. Again, really small. And in a RAID 0, what happens is we take the data and we send it to drive 1. And then the data goes to, let me go move this a little lower so you can see that. So in this particular environment, what you'll see is we have data that's going to be saved. And the first piece of the data goes to the hard drive 1. The second set of data goes to hard drive 2. The third part of data goes to hard drive 1. The fourth part of data goes to hard drive 2. So what's special about this? Well, let's assume each one of these drives are 200 megabit/second. It's a little fast for magnetic, but some can do this. Oops. So if we have in this RAID 0 environment where we're load sharing by putting half of the data here and half of the data here, if each drive is 2 terabytes, guess what? We have 2 and 2 as we have 4. If each drive can do 200 megabit per second, now we've got 400 megabit a second because we can share the load. And if we wanted to add a third one, we could do that too. We could have a third drive in this particular environment. Now we put 1/3 of the data here, 1/3 of the data here, 1/3 of the data here. This is RAID 0. Now, what I want you to see here, what you see is each drive adds incremental capacity. Each drive adds incremental speed. But here's the problem with RAID 0, or the challenge. If we lose this drive and 1/3 of our data is here and 1/3 of our data is on the second drive, but we lose the third drive, we've got absolutely nothing left over. So this tends to be a little scary. So RAID 0 is generally speaking a little too risky for the enterprise. Now, where would we use typically RAID 0? If we had a video editor that needed high performance storage, we might take a whole bunch of drives and put them in a RAID environment so they could get real fast things. The video editor would work with their film while it would be in RAID 0. And when they would save it or export the film, they would save it to another drive that was not in RAID 0. RAID 0 is really fast. So if RAID 0's if RAID 0 is the fastest, let's talk about the next kind of RAID, which is going to be RAID 1. I'm just going to actually steal some of these drives so I don't actually have to draw them both. Now, in this particular case, with RAID 1, we do something very different. In RAID 1, we take some data and we send it to the first drive, and whatever we put on the first drive, we immediately copy to the second drive. Add data to the first drive, copy data to the second drive. So what we have here is this drive is always being copied to the next drive or mirrored. So this is RAID 1. So because the data from hard drive 1 is going to be directly copied to hard drive 2, they're going to have identical data. Now, what does this realistically mean? It means if this hard drive is 2 terabytes and 200 megabit per second, and we now have 2 of them, the capacity is only 2 terabytes because the other one is a backup of its data or a mirror. This is incredibly highly redundant storage. This is RAID 1. Here's the problem. We add disks and we get no additional speed or capacity, so it gets expensive. That doesn't mean we shouldn't use it. It means we have to use it under the right circumstances. So the next thing we typical will see in the enterprise is what you're going to see is RAID 5. And we're going to see this all over, whether it's RAID 5, whether it's RAID 6, but some flavor of this. But you're going to see this all over in enterprise computing, especially in private data centers. And then we'll talk about why you won't see it on the cloud. But in RAID 5, what happens, we combine the performance of multiple drives and the capacity of multiple drives, and we still create redundancy. So what happens in RAID 5 is this. Data is written to the first drive, and then data is written to the third drive. And then data is written to the first drive, the second drive, the third drive. And then some kind of weird backup data called parity data is added to the fourth drive. Now, the next time data is written to the first drive, data is written to the second time. Now we put a little backup data on the third drive and write data to the fourth drive. Now, the next time we write to the first drive, we put some backup data on the second drive or parity data, and then we add data to the third and fourth drive. The next time we put backup data on the first drive, and then data, data, and data. So what happens is we're spreading the data, and we're always using one of these hard drives as backup data. So if anything were to happen, like we were to basically lose with this one drive, all these drives have the other 75% of the information. And they also have this the leftover 25% remaining data spread across these systems. So all that needs to happen is you pop in what's called a new hard drive into the space. You ask the RAID array or your RAID system to actually rebuild it. And what'll happen is it'll take all the backup data from this drive, and this drive, and reconstitute it as real data onto this hard drive. And then your RAID array is up and operational. So in the data center, in private clouds, you're going to see RAID 5 everywhere because it's cost efficient, it performs relatively well, and it's got redundancy. Now, you won't see this on the cloud. The cloud providers will not let you do this. And here's the reason. And then I'll show you what you can do instead. Cloud storage is really, really slow. I mean, sure, if you take an AWS exam, they'll tell you elastic block storage is fast. Azure and Google will do the same thing. And when it comes to the storage in the cloud, yes, it is fast, but I wanted to put it into context. I can get 19 million IOPS right now in a server. 19 million. The fastest block storage volume I can get from AWS is 250,000 IOPS. So I can get 19 million in my server, but I can get 250,000 with the fastest block storage available in AWS. So what I'm talking about is I'm getting 80 times greater storage performance in my data center. So why does it matter? Because every time we write backup data in RAID 5, when we write data, backup parity data, every time we write that parity data, that takes time, so it increases latency. So because the cloud storage is so slow by compared to what we can actually access inside of a server, inside of a data center, we can't slow it down even more by using RAID 5. Now, in our hardware and our data center, you're going to see this all the time, but you're not going to see it on the cloud. So how do we get high performance storage on the cloud and high availability? Well, it's going to get real expensive, but I'm going to show you how to do it right now anyway. So in this particular environment, here's what we do in the cloud. Let me steal these real quick. We actually do something called RAID 10. And RAID 10 is basically where we take RAID 5. Let me just do that. And we use RAID 0 and RAID 1 together. So if you'll recall, the fastest of the storage that we had before, if you'll recall, the fastest RAID option before was RAID 0, where we take data and we put it to data, and we'd write to the next drive data and the next drive, and then it's data, and we're only writing data to these drives. Now, you'll recall with that RAID 0 environment, which is exactly what this is, the weakness to the system is if we lose any one drive here, what we ultimately have is we lose all the data, because it's an all or nothing thing with data. So if this is RAID 0 over here, if we lose any one of these drives. Now, what we can do is, and this is really our only option in cloud computing when we need really high performance storage, is this. We take another set of 4 drives over here. We create another RAID 0 environment. So I've got, if I need 4 drives in my first RAID 0, I need the same 4 drives at the same capacity in my second RAID 0 array. And then in this particular environment, what we do is we run RAID 1 between these drives. So I'll show you what I mean by this right now. So now, because we have RAID 10, so what happens is this first array, data, and then it'll go back and it'll be data. As data is being written to these 4 drives, that data is being immediately copied to the next 4 drives. And that way, if any of these drives fail, you have a mirror or a complete backup copy to the data above. So that's realistically with our option in the cloud if we need high performance storage and we need redundant storage. And that is called RAID 10. And why is it RAID 10? Because it's RAID 1 plus RAID 0. And we know how techies like to be. They go 1 plus 0 equals 10. I didn't make it up. That's how it was named. So now we'll briefly, I hope you enjoyed that demo on RAID. If you enjoyed that demo on RAID, maybe give me a hashtag RAID. All right, so let's talk briefly about data resiliency. And under here, we're going to talk about data dispersion. So, would you, realistically speaking, buy only a single stock for your entire life and put your retirement net income in one stock? I probably wouldn't. I wouldn't put my mission critical systems in a single cloud if they were mission critical. And I would never put all my eggs in a single basket, because if I was hungry and I put all the world's eggs in a single basket and something happened to that basket, a lot of people were going to be really hungry. So that's not a good situation either. So data dispersion is about putting your data in several different locations. So if one data center has a problem, you've got a percentage of it otherwhere else. So, this is not like it's a really uncommon kind of thing to do. So just think about not putting all your eggs in a single basket. Now, we also want to think about access controls for remote access as well. So, what are we talking about here? So, remote access can be, typically speaking, one of two things. If it's Windows, we're typically using remote desktop protocol. And that's a Windows native tool to basically be able to remote administer another Windows system. Typically speaking, with Linux, we're going to be using SSH, TLS, or security, that kind of thing. So we have that, but these are going to be over a private and an encrypted channel. Now, if we're going to be using these remote systems, well, ideally they're being accessed over a secure network like a private line as opposed to the internet whenever possible, or at least during a demilitarized zone that's properly protected. We want to make sure we're using at minimum strong passwords, ideally multi-factor authentication, really strong user restrictions. And if we have a system that we're going to administer remotely, it should be protected behind a firewall, meaning we're going to create an IPsec tunnel to come in, or we're going to be using a private line to come in, or at least we're going to have a server that's out there. That server is going to have to be properly hardened and properly protected in a good demilitarized zone, something. Now, in certain cases, if you really wanted to get secure for your management, what you can do is you can have a management subnet inside of your building where people on this subnet can actually reach your systems to be able to manage them. And potentially you could lock it down that you have to be inside of this room in order to be able to obtain the right IP address to be able to manage these systems. So lots of opportunities that we can do. We also want to make sure that we secure the terminal or the console access. So if many of you are not familiar, many devices have something called a console port, and I'll show you what this console port actually is. So if this is a router over here, for example, or a network device, you can always, if it's, let me just call it a router over here. Typically speaking, if it's got IP connectivity somewhere along the line, you can say SSH into it if you have IP connectivity. This is called in-band management of systems over the IP network. But if you didn't have an IP network, these devices have something called the console port. And a lot of devices, we have the equivalent of a console. And what you can actually do here is you can plug a cable into this console port, attach it to a computer, and from that cable, you have now full control of this device. And you could attach a modem to this and dial up of a phone line. But here's the remember, this console port, you got to block that. Because if you can make it that anybody can plug into one of these devices, they can initiate a password reset on the device if they know what they're doing. And then they can go to the management things and make it so they can log in and do whatever they want to your network. So devices that have consoles, secure them. And whether it's a remote console, the equivalent of, say, the AWS management console, or whether it's a console on a router or a switch or a firewall or a storage device, lock it down. And we will talk about why you should never use a Bastion host at some point for remote access. Because since we're talking about remote access, let's talk about why the Bastion host is most likely the biggest security risk in the entire world. So let's talk about this. Here's what a Bastion host is. And we'll talk about why this is, typically speaking, so scary. And we'll talk about why major businesses don't do this. So here's the internet. Now, the internet is the least secure place in the world. Unless you are absolutely knowing what you're doing, you put a system on the internet and it's going to be hacked pretty quickly. And if you look at your firewall logs and you see the number of times a day people try to hack you, it would amaze you how many times a day people try to hack you in your own home. But in a Bastion host, you put a computer out here in the middle of the internet, and it's connected to the internet. So you can connect to this device in the internet. The Bastion host has the second network card inside of it, second NIC. And that NIC is a backdoor to your internal network. It's actually attached to your internal network. So you got a couple of problems here. Anybody that can figure out how to get into this Bastion host, which in most cases is not going to be that challenging, now has access into your internal network. This is bad. Now, the average person that's popping a Bastion host does not know how to lock down a virtual machine to make it harden. And what do I mean by that? Knowing which packages to remove, knowing which unnecessary services to remove, to put the right host-based firewall on it, to put the right anti-malware protection, to be able to install the right things in the operating system to be done. Not just that, this Bastion host is now sitting out on the middle of the public internet. So assuming the person can figure out how to lock it down, it's still at risk for being shared. Oh, am I not sharing this? Okay, so apologies for that. So let me go back and walk through this. So here's what a Bastion host is. I have got this device out there. It's a computer that you stick on the middle of the internet. The internet here is where all the scary hackers are. The Bastion host has two network cards on it. It has one that connects to the internet and one that connects to your internal network. So basically speaking, you just put a host on the internet with a Bastion host and used it and created a backdoor into your internal systems. Now, here's what's going on. This putting a computer on the internet by itself without being properly firewalled off, that thing is going to get hacked pretty quickly. And now this thing gets hacked and anybody can come inside the internal network. So this is an absolute nightmare. The person that's going to build this host has to know so much about operating system security. And they're not going. Now, if, for example, they were in an environment where they were a Cisco or a Palo Alto or a Fortinet or a Checkpoint, and these organizations invest hundreds of millions of dollars learning how to secure operating systems and secure devices, sure, they'd be okay at locking that system down. But you'd still have the problem that the system's actually on the internet with a backdoor. Now, this is risky because you're going straight from the internet into a server backdoored into your network. So what normal businesses do, or businesses that have high security, is they have users on a specific perspective. The users are, say, in a campus. The cloud provider is over here. They have a wire in between them, like a private line or a direct connection. Then they typically run encryption on top of this. So on top of the private line, you would do something like IPsec encryption. And then even with your IPsec encryption, you could still use SSL. You'd still be using SSH or SSL underneath it. So here you're accessing your systems. You have to be on the network. And if you're not going to do something like that, at least your remote access people are going to do something. For example, they'll have an internet, they'll have the internet, and then they'll have a next generation firewall. And then behind that, they'll go to a security appliance called the VPN concentrator. And at least in this case, you've got the internet, the next generation firewall blocks 100% of everything coming in. And then when you get to this VPN over here, the only thing that's being allowed to even see this VPN remote access device is going to be IPsec traffic. Whereas what you got here, pretty much everything can be seen. But at least in this particular case, either you're accessing it over a private network, which is going to be the most secure thing, or you're creating a VPN remote access where you've got extreme control over who can route to whom and anywhere in between. So Bastion hosting is definitely something you don't ever really want to use for remote access if you don't have to, because you're opening up just so many security violations. Now, that's going to be different than the cloud providers that have their own Bastion host service. That is an actual remote access service. This is what we're talking about, is what people were learning in their AWS certifications and they were creating as a cloud project. And that's the stuff that gets you hacked. not Azure Bastion service, because all that is a managed service from Azure where you connect to it and then it gives you access to the systems. That's a completely different environment. Okay, so let's talk a little bit about remote access. So, and let's also talk about the difference between IAM, because the question was popped in the chat box. You can use IAM to basically say someone can't access it. And IAM is the equivalent of someone knocking on your front door. You look and see who's at the front door and you don't open your door. That's identity and access management. What I'm talking about is saying that the person should, that not only the person will never make it to your front door with these firewalled environments, that they're all blocked off the entire world except for this traffic is even allowed to enter the front door. So we've got 90% of our security out of the way before the person's there for the IAM to work. I kind of hope that makes sense. So let's talk about access control. So whenever we're dealing with it, make sure the machine is treated like it's a local system. Anything that you're going to be remote accessing to needs to be locked out, and ideally it should be secured off from the rest of the environment. For virtual practices, some common things that you want to do for virtual machines is you typically don't allow copying clipboard data. So I don't want somebody to be able to remote access into the systems, copy data, and then pull it out. Specifically, if I'm using like a Citrix environment or remote desktop. If I'm doing some kind of a remote desktop, and I'm talking, there's a difference between a remote desktop and remote access. I might be doing a remote desktop where users control a remote control a system that's housed in the cloud or the data center. I might do that to keep the data housed in the data center, then it doesn't leave. But same kind of thing. I don't want people, if I'm going to be using remote access for a virtual client or controlling a virtual system, I don't want to be able to take data from that virtual system and copy it back. And in any case, whatever I'm going to do, if I'm ever dealing with a virtual remote control system, I am going to go to every effort I can to lock that down, protect it behind a firewall, security groups, ACLs, host-based firewalls, host-based IDS, IPS systems, locking down that operating system. Now, sometimes organizations are thinking about virtual clients for remote work from home environment too. And think about this from a complexity perspective. And this is why some organizations are using virtual devices. So I never had a Windows machine until 4 months ago, but my M2 Ultra Mac couldn't handle my video encoding needs. Literally speaking, it was dropping frames. The GPU was hitting 100%, so I had to get rid of it. But I was using a Mac, and I've been on it. My buddy Greg, where we used to work, was using a Red Hat box at the time. Somebody else is using a Windows system. Somebody else brings in their own little Chrome notebook. Now, sometimes you work in companies where people bring their own devices. How do you manage the security of that? It gets pretty icky under those circumstances. If you can mandate everybody's on a certain operating system and you can push passions to it, it's pretty easy. And when the company provides the devices, they can do this, but it's kind of hard to force requirements to somebody else's personal device. So some companies do this bring your own device, and then they have a remote access desktop. By doing so, they maintain the data in a single place. The data is stored inside of that data center. It's easy to make sure all the systems they're using are locked down properly behind firewalls and secured. So you may also see those types of remote access environments also used for remote desktops. Now, when we have security, we have to make sure we've got some type of oversight of what's actually going on. We have to be able to keep track of what's going on. So we need some kind of monitoring in place. And typically, you'll see things like network operations centers, security operations centers, where they've got monitoring tools. They're looking and seeing what's going on. They could be looking at SIEM systems. They could be looking at firewall logs. They could be looking at all kinds of things. So, in a big company, there may be a large number of monitoring staff. And that could be something that we're actually dealing with. In a small company, they may not have monitoring things. They may pull from people and then have systems which send you messages. It all depends on the size of the business and what their needs are. So the next topic is a security operations center. Mark, how long has it been? So now I got pretty geeky and RAID and a few other things. Mark says we should take some questions.
Yep, let us take a look and see what questions we have here. From Cloudy, is decreasing the trust score something that will be configured in the Identity Access and Management Center? No, Cloudy, it would not. When it comes to zero trust, the trust engine is a system that's going to take into consideration a lot of different contexts. We generally call that type of system like a multifaceted system, and it's going to use different technologies and different tools. For example, the Identity Access and Management System will be one of those context tools that the trust engine would consider when it makes its final calculations. But at the same time, we're also going to be considering things such as, did the user authenticate with multi-form authentication? Did they have, for example, an endpoint detection and response system installed? It could be other things such as simply, did they have a certificate installed that would identify the device itself? So there's multiple things that would go into eventually calculating a trust score, which then would have to be monitored and is then dynamic and be able to pull it down and pull it up depending on what perhaps changes. So when it comes to zero trust, you have to think of it, there has to be a lot of context fed into these different engines. And depending on the implementation, and this is one of those issues I found with zero trust, there isn't always a lot of standardization yet in regards to the implementation or even how you collect information. But for example, Netscope, which is a company, they do provide their own solution when it comes to something like a trust engine. But to answer your question, the IAM access, the Identity Access and Management component is just that, a component of zero trust. All right, let's take a look at the next question. And this is from Anthony King. They're wondering, storage is the main being able to be provisioned from any location. For availability reasons, can vendors legally be prevented from crossing geo boundaries, such as GDPR in the case of the European Union? Let's rephrase that a little bit, just so that we understand. You're 100% true. This is one of these advantages that we have when we use one of the cloud service providers, this ability to spin up our resources on demand and to be able to use them such as storage. But in this case, the cloud vendors, they are going to be following compliances and legalities of their jurisdictions already. So it is going to be up ultimately to you to make sure that you also know, based on if you have like a governance and compliance and a risk management tool, that you make sure that you're not breaking these boundaries. Because in the end effect, the cloud providers, again, when we think back of the shared responsibility model, they're going to be doing what they need to be doing from a legality standpoint, because they have way too many customers to worry about. So you're really going to be that person that would be able to break something as crucial as making sure that the boundaries are set and that you're not removing data from one geolocation and moving it into another location, thus breaking such things as the GDPR. Okay. Let's see what other wonderful questions you all had. So from Chad, they're wondering, what are the best practices in whitelisting? And are they at the server level or at the network layer? Chad, I am going to provide you, once we get back to the content in a few minutes, and this is for everybody too, I am going to provide you all again with some additional goodies, some additional reading. These are going to be guidelines provided by the National Institute for Standard Technology from the United States. The reason I'm providing that generally is a lot easier to find and read. Sometimes what happens with the ISO standards is that it gets convoluted in how you can find them, because they first try to get you to pay for them. So you got to really search through them and find the applicable standards. But in case what you mentioned, you'll find more details in the actual documents that I'll provide. But just to get your juices flowing a little bit, if I wanted to whitelist something, things such as, let's say, file attributes would be important to me. So I'm thinking about name, path, size, things that I can compare and contrast and eventually actually write policy against. And then the nice thing also is a lot of applications these days, especially if they're executables, if you want to run like portable applications, they're going to have some type of digital signature or some kind of cryptography type of file hash. And you can also use tools to compare that particular hash or this kind of codified message that you get to make sure that the application is also valid and has not been changed from its original author or publisher. What you can do that, you can actually feed that into your policy engine based on how you want to do this, either at the firewall level or if you have some ability to do that, let's say at your virtual machine manager, you can do it there. And it will do like an integrity check against it, make sure that wasn't changed. It's very similar to when you think of the firewall when it does its actual digital signature check. It's the same idea behind it. And then you can take that and you can make sure that as long as it's not changed, that you can whitelist the actual application. So that's probably as nerdy as I can get when it comes to system administration. So I'll leave it at that, but I will provide you some additional resources that if you're really curious about the nitty-gritty details, you can read them there. From Kennedy, in the case of enterprise cloud computing architecture, where we have multiple storage hard drives, if the drive with the operating system is infested or compromised, does it directly affect the others?
This is one of those situations where it's going to really depend. It's going to depend the way the malicious code is written. Some malicious code is basically out there going to encrypt what's on your data and hold you for ransom. Other malicious code is going to hit the CPU and it's going to ask the CPU to spew out worm and network traffic over the entire environment. Other worms are going to have your CPU or GPU mining cryptocurrency. Other ones are going to go through your contact list and then email people. So it really depends on the kind of malware that it's actually being infected with. The real case here is we have to deal with so many systems and there's so many different things that can go wrong. And that's why we can never say this is the best approach or this is the best approach, because in all cases, there's so many different factors. It's more about what kind of challenges that we think we're going to see, what are the targets, and then we can plan for it. What are the goals? What kind of risks can we tolerate? I hope that makes sense. But yes, it can. It can infect the whole data center.
Yeah, and I'll add this to what Mike was saying. In a well-designed data center or a cloud architecture, generally you would have isolation in place, segmentation, and that would be at all layers, from physical to logical. This would include your storage area networks and same your hard drives. So that way you're already limiting this lateral movement that the malware or whatever you might have trying to infect the system. Now, there, of course, is going to be other best practices that you can do, but again, I would probably say these are more implementation type of details when you think of implementing access controls, encryption, and patching the systems and so forth. Just to give you a few. All right, let's take a look at the next question. So for remote access for Windows Server, which one is preferred? Using a custom RDP port or using Bastion host?
Neither.
It depends, yeah, what you want to do with it. But there's always better ways of providing access to your server than using a middleman or doing RDP. You're not going to be using really either of them. There's better ways of doing that, definitely.
And the key, there's a lot of ways. So what are you doing? But honestly, sending it over a private in-band network, over an encrypted channel, potentially using double encryption. So it all depends on what we're trying to do. But I wouldn't. There's a lot better options.
Definitely. So from Cloudy, do all console ports use COM ports for network security, for network devices, networking? I think when it comes to the software, as far as I remember, it's been a while since I physically actually plugged into a switch or a router. They're all going to be, from a software perspective, seen as COM ports. Uh,
Yeah.
but if you use them, like, let's say, a mini USB kind of connection, which many of the new devices have, some even have, USB-C. As long as you have the proper drivers connected to, let's say, your laptop or something, they will actually show up as USB connections instead of COM ports. But traditionally speaking, yeah, it's going to be COM ports from the system. All right, some more Bastion host questions. Says, for remote access, are Bastion hosts the same as bridged or bridge computers? Uh, they're two completely different things, Cloudy. Bastion host and okay, the definition of the Bastion host is something that is a secured computer, right? That allows you to be able to go from a little bit more unsecure zone into secure zone. We don't believe in how great Bastion host is, but that's what they're used for. When it comes to bridge computers, it's a little bit different. You're looking for a computer that can bridge two different network segments into one and then allow you to have some type of communication across those segments. But it's very specific in regards to also destination and source MAC addresses. So they're quite different in their use, definitely. Okay. And the next question is from Cloudy. It says, you mentioned Zscaler a few days ago. Why can't we use Zscaler ZPA to regulate access to the server? Well, Cloudy, I don't necessarily recall when we mentioned Zscaler a while back, so I apologize about that. But there's always different tools to accomplish the same type of job. So you can definitely go ahead and use Zscaler ZPA if you wanted to, let's say, have remote access to applications. But again, it comes off to the trade-off, right? In this case, what we're really talking about, Zscaler ZPA might be great because it focuses on application level access, not so much on the server access. So you kind of have to take a look at whichever tools you're trying to use, what are their strengths and what are their weaknesses. And don't try to fit a tool to do something that it wasn't designed to do. So for example, what you're mentioning right here, probably not the best tool to use when you're looking for server access. All right, Mike, I'll let you answer this one. More Bastion hosts. It says, what is the difference between the traditional Bastion hosts and cloud provider Bastion hosts, such as Azure and AWS Bastion hosts?
So a traditional Bastion host is what I showed you, which is introducing a massive security nightmare and backdoor into your system. A Bastion host made by the cloud provider themselves really isn't a Bastion host at all. They're basically giving you a secure connection to the cloud, and that gives you backdoor access to it. So that is a system that's designed to be secured. It's firewalled off, like we were talking about. It's locked down. Its operating systems are hard. So that's just a cloud-based remote access service versus a homemade, in my house, remote access system that's more likely a backdoor into my system than secure access.
All right, good. Let's take a look at the next question. One more statement. Says, Cloudy, zero trust combined with data loss prevention is the best way to manage bring your own devices, in my opinions. It is one way of managing it.
Yes.
With zero trust, there is a lot more, of course, and it looks like you have some familiarity with it that you can implement on how you're going to go about the authentication, authorization, and the monitoring stages. So it really depends on the environment. And again, if you're starting off what we call a brownfield environment, something that's already established, you want to use the tools that you have available to accomplish the job. So in this case, if you have a data loss prevention system, definitely use that in conjunction with what trust engine and policy engine and endpoint enforcement engine you have in place to be able to manage your bring your own devices.
Yeah. And you have to weigh all options.
So from Kwaku, they're wondering, so RAID 10 is always 1, then 0, never 0, then 1?
RAID 10 is always two RAID 0s arrays with RAID 1 mirroring between them. So I don't really understand the question.
It's a combination, Kwaku, right? So it's more semantics and how you answer it, but it's a combination between the different rate versions. But if you like, you can always clarify your question a little bit more for us. All right, from SR, it says, in a multi-cloud hybrid scenario, what would be the logics behind 1, centralized monitoring across all environments, 2, single pane of glass, 3, central log management, should log storage be dispersed or centralized in cloud or on-prem?
Okay, so I'm going to touch that one. SR, what are the business needs? What are the business goals? What people does the organization have? What part of the world are the people in? How does the business operate? What are its challenges? What's going on with its current systems? And what might we need to do in the future? If I don't know that, there is nothing that I can design. So there we run into trouble, and the reason between 7 and 8 out of 10 technology projects fail is because people are already looking for the tech. They already want to know what the monitoring should be, where it should be. How do I make that determination until I know what the needs are? I can't. And there is no best practice. There is no best location. Maybe I've got one organization that's got 3 different clouds that they're using. And in their cloud, one of them is for AI, but they just happen to have the best people. They may have 2,000 data scientists and AI architects that are sitting in an environment. And in the next environment, I got a whole bunch of network engineers that are running a high performance, low latency cloud. In another environment, I've got something, maybe I need different sets of schools. And okay, SR, you said in a banking environment. So the next question I ask you, are we talking retail banking? Are we talking trading? Are we talking investment banking? Are we talking options trading? Again, every one of these is going to change. And every bank is there. So a high secured financial environment, again, SR, you're already too far away from actually finding the business problem. What is the security value of what they're protecting? How many billions of dollars do they have on management? Where is that actual secured? How are they with regards to their reserve requirements? What kind of systems do they have? Do they have an algorithmic trading system? Do they predominate retail trading systems? It's going to take a year in one of these environments to actually get the questions before we can answer that question. So I'm trying to show you why it typically takes an architect like me to build a team of 15 to 50 people to spend 3 to 6 months to figuring this out. If you've already solved the problem, you've already missed the entire opportunity. We don't know yet. I kind of hope that's trying to get there. We can't have a solution. I don't have a pill to give Mark because Mark called me and he told me he didn't feel good this morning. Now, if I speak to Mark and I find out he has a headache, for example, today, I don't know what Mark has today, then I might ask him the characteristics of that pain. Is the stabbing thing right over here where I got to be worried about a cluster headache? Am I worried about temporal arteritis? Do I think he has a tension headache? Do I think he has a sinus headache? Do I think he has a migraine headache? Do I think he has an atypical migraine? Am I concerned that he's got a high blood pressure induced headache? Am I concerned that he's got a brain tumor? Does he have a blood vessel that's turning into an aneurysm? Every one of those things can cause it. And the way I have to do that in medicine is identical to what I have to do in architecture. There is no best practice until we understand what the needs are. And that's where the assessment takes. So that's why I can't give you that kind of an answer in a chat box. I will tell you the solution to what you're actually describing will turn into a 300 to a 500 page document that's going to be presented to the client that's going to explain how every part of the system works. So I kind of hope that actually makes sense. And I work in all high security environments, but they're all different. I've done, a military base will need something different than an investment bank, which will do something different than a trading bank, which will deal with something different than something that doesn't. There are lots of different businesses.
All right, let's take a look at the next question. Okay, so what we'll do is we'll continue with the content. Whatever other questions come up, we'll answer them and we'll address it. But definitely what I want to let everybody know is try to consider different things that you hear as they're being brought up in the content
Mm.
from a high level perspective. Because what's going to happen is you're going to look at some things that you're familiar with and then go down the rabbit hole.
Yeah.
And I'm not trying to discourage some good discussions that we can have. But if you're talking about something as, let's say, specific as policy, as code, that's going to be very specific depending on, again, what your business need is. Like, for example, I'm quickly going to say it. You asked, do we still need to create lock analytics, system lock and storage? Yes, you do. That is the answer. But how far you're going to go with that really depends on your environment and eventually also
Yes.
what the business use case is.
Yeah.
So keep up the great questions, everyone. Try
Yeah.
to do your best to stay within the scope of them, and that way that we can make properly address them for you all. Okay. I'll hand it back over to you. Oh, we have one more question from Kwaku. Okay, it says, I was asking if the data was mirrored, then striped across multiple disks, or could it be done the other way around?
Okay, I
Your
understand.
rate question.
So let me go back to this diagram because that's a great question. So realistically speaking, what's happening is whatever is written to this drive, this RAID array, is going to be mirrored to the second one, which means the data is going to have to be written to the top drive, the top array, before it can actually be copied to the second, because it won't know what it's actually copying until it's all reconstituted. I hope that makes sense. That's honestly, it's a pretty detailed, pretty thought-provoking question. All right, so make sure you come on Thursday to the How to Become an Architect if you have a desire for an architecture career, because we're going to dive deep into what we actually do in this world, and we'll talk about the right set of skills, the right way to thinking, because it's a completely different kind of world that's so different than engineering or other roles. That if you get it, and as soon as you understand it and you go down that direction, you're going to be terrific. So for architects, join us on Thursday. Tomorrow night, on Wednesday night, we're going to talk about health. We're going to talk about careers, and any of you can join us. And you can ask us any questions about any careers. And if you want, I'll give you some guidance. Like, there's certain things that I can tell you that if you change your way of thinking, it can easily add an extra $50,000 to $100,000 to your salary, and it's going to be practically overnight. And some of those things are the way you approach things and the way you convey that. So we'll have some fun. I'll answer some questions, and if you ask me for a couple of quick tech secrets on how to earn more, I'll give it to you too. So come and have fun. And my team popped a link to those sessions. Hope to join you. And we're going to get back to the content. So if you haven't given it a like, give it a like. If you're not a subscriber, please subscribe. Hit the bell to be notified of new stuff to help you in your career. So now let's talk about security operations centers a little bit more. So give me a hashtag CCSP, everyone. So if we've got a security operations center, and this is going to be a build facility, and it's going to have people in there, and they're going to be monitoring data, we want to make sure we restrict access to the people that need it. And whether it's, they're coming into that security environment center or they're remote accessing in, we need to be very careful that this environment, our security operations center, is getting the information. So there'll be lots of tools these individuals are going to be getting. They're going to be getting all kinds of logs and notifications from SIEM systems. They're going to be getting all kinds of systems. They're going to be managing firewalls in this thing. They're going to be dealing with the IDS, IPS systems. They'll be involved in managing other security devices, the security operations center. So it's going to typically be like this. And here's typically the flow. You got an architect like me that designs it. And then an engineering team comes in and builds it. And then at some point, it goes over to these monitoring people. These are the operations people that are there that are going to patch these firewalls and do the day in, day out kind of maintenance of the systems. Now, if you're going to have a security operations center, where do you put it? I mean, it doesn't necessarily have to be in the physical data center. So if you happen to be a company and you're a global company and you have a ton of cybersecurity people in a certain area, as long as they've got connectivity, they don't necessarily have to be there. So they can be remote. And there's honestly a trend towards third-party remote monitoring. As you can see, a trend for cloud computing, as you can see a trend from buying something to paying monthly payments on it. Lots of people are outsourcing security operation services, and that's okay. So, with regards to cloud managed services, a cloud provider is typically going to have a SOC team that's going to be overseeing their data centers and making sure they're doing what they're supposed to. Their infrastructure is doing what it should. Their platforms are doing what they should. Their applications are doing. But you'll be able to monitor your own accounts, and the customer may have their own security operation centers that actually monitors what's going on in AWS, Azure, Google, Nutanix, OpenStack clouds, their VMware cloud, all of it. It's going to be from all over the place, and realistically speaking, there's going to be a shared responsibility. So hopefully, your cloud provider tells you there's something going on, or there's a hacking event, and then something else is going on. So kind of think about these things. These responsibilities should be whoever's dealing with should be spelled out. They should be there. They should be clear. Everybody needs to know their job and how their job will be measured. Now, when it comes to these systems get hacked or people try to hack them constantly. So they should be monitored continuously around the clock, 24 hours a day, 7 days a week. And you're monitoring the systems to make sure they're working. You're monitoring for incidents and breaches and other problems that are occurring, but you're making sure the systems work. And sometimes when these systems fail, they can fail open and they can fail closed. And a fail open is, okay, the firewall fails, so all traffic comes in. Or they can fail closed where the firewall fails and then nothing else gets in. Now, firewalls and network security groups or ACLs, they typically generate logs, whether it's NetFlow logs, VPC flow logs, some kind of logs that'll show your traffic. That'll give you a lot of information. It'll show you what's going on inside your systems. Your IDS, IPS systems, those intrusion detection, intrusion prevention systems, they're going to generate all kinds of logs. We talked about the creation of honeypots earlier, and if you have a honeypot, that's going to generate a whole bunch of logs. Now, thankfully, we're integrating a lot more AI and machine learning into what we do right now. So a lot of these tools can use AI to kind of give you a better picture of what's going on. A lot of the SIEM systems are already using AI to try and correlate events and help give you something. So that's regarding security operations. So let's get into the fun stuff, incident management. So like what happens if something occurs? So most of my life was, at least my youth, was spent responding to emergencies, either when I was a paramedic on ambulances or working in the emergency department. And then I went into tech, and you know what happened? I was one of the few people that could actually figure out networking and understand it and how to redesign it after things would break. So my whole life has been all about firefighting and networking too. And I can tell you that when things go wrong, if incidents are managed correctly, it's no big deal. Everybody hums together and it gets fixed and it's smooth. If incidents are not planned, whoa, bad stuff happens because no one knows what to do. There's stress, there's chaos, and it all falls apart. So we need a good incident response management plan. And here's the key of an incident response plan. First, you've got to plan it ahead of time. And we're doing it because we want to minimize the losses that occur. Okay, we're getting hacked. We know what to do. We know how to stop it. Damage cut off fairly quickly. The next environment is we have to make sure that our systems are constantly operational. And while we're dealing with a security attack, if we occur, and how do we prevent the attacker from increasing the attack on us? So we have to think about it. So let's first think about the impact and then the response. So if an organization was hit with a bunch of DDoS traffic on their website, and they're on the cloud and they can add web servers dynamically through auto scaling, What if that company spends $50,000 in the next hour for auto scaling? Well, that might be nothing to the business if it's going to keep them from getting, 20 or $30 million in sales. By comparison, if it's a small business, $50,000 might bankrupt them. So the organization has to plan this kind of response and what they're going to do ahead of time after analyzing all these risks. Now, in the end of the day, the cloud provider needs their incident response plan, and you need your incident response plan if you're dealing with the cloud. And there should be some coordination whenever possible, but the shared responsibilities will need to be clearly defined in contracts that are going back and forth. Whatever the real case here is, it's about managing whatever challenges are going to be there. So somebody has to be there to make decisions. There has to be an agreement between whatever parties are involved in an incident response plan. Maybe you deal with a cloud provider and they give you an SLA. What happens when they don't meet their SLAs? What happens if you have to allocate costs? Because downtime costs a lot because revenue may not be coming in. Organizations may have to spend some money during downtime to get up and quickly in a fix. And sometimes emergency spending gets pretty expensive. Some things to think about for incident response policy and plan is to have very clear incident management protocols. Make sure you define responsibilities of who's going to do what ahead of time. And make sure there's a very close or a tight alignment between the goals of the response and the methods that will be being used. All right, now we're going to briefly start introducing the concept of operations management. And this is about systems that are consistently running. So if we have systems that need to run 24 hours a day, 7 days a week, 365 days a year, we need to know a lot about our systems. For one thing, we need to monitor them, because imagine we're running systems on servers that are bigger than they need to be. We're going to pay more for them. That's just one thing. We have to know what's going on our servers. Are they healthy? Are they running out of DRAM? Are they running out of drive? Are they running out of disk performance? And we have to be able to plan around it, because if we don't know what our capacity is from a capacity planning perspective, we're going to overpay for it. So again, we need to know what we're doing. So there's going to be, when we're dealing with these levels of management, things that need to occur from a monitoring capacity and a maintenance perspective, we've got service level management. Okay, the cloud provider guaranteed us this. Are they meeting that? We have availability management. Okay, the systems need to be available everything but 52 minutes per year. Are we meeting that? Or are we down 4 hours this year? Capacity management. Does that direct connection we have to the cloud have enough capacity? Do those servers have enough network capacity, DRAM capacity, CPU capacity left? Are we running something in a GPU? Is that GPU running at peak capacity? Is it slowed down? Is it not giving us exactly what we need? So how do we monitor? Ideally in real time. To a degree, we want to monitor software, hardware, network components in real time. We want to see what's going on. We want to identify systems running at capacity or nearing capacity and figure out what to do with them. If we're on the cloud, maybe we add another server, but maybe we reserve that server for 3 years because we get a reduced price. If we don't know if it's long-term, we can use auto scaling and we're going to pay substantially more, but we get access to the hardware. We just need to know. We need to monitor. And we're going to have to find systems that are running, and we're going to have to make sure we understand. We're also going to have to log what's going on in the operating system. We want to know when the CPU is too high, when the memory gets too high, when the disk is used too much, if we're hitting the page file or the swap file too much. We want to get information on our disk I/O performance. If we are considered the technology provider for the business, and the business needs 5 nines availability, and we're not delivering, or we're not meeting our SLA to the business as a technology team for the company. Now, the cloud stuff, that's going to give us lots of logs too, so we want to monitor them as well. So lots of information for lots of monitoring. But we don't want to just monitor that stuff. We might want more. In our data centers, we might want to know what's going on with our CPU temperatures so they don't cook. We may want to know what's going on with our fan speeds or our voltages or the CPU load. What's going on with the temperatures of our devices? Are they getting too hot? Are they throttling down because they're too hot, reducing our performance so they don't burn up? Now we've got to monitor the network. Monitoring the network hardware, like the routers and switches, for example, the software running on the operating systems running on the routers, any kind of SDN or software-defined networking control plane we may have. We need to make sure that our network has sufficient capacity and is going to support the needs and the scalability needs of the business. And we want to make sure that our networks aren't overburdened or overly congested where we're going to have unacceptable latency. And if we do, what kind of congestion avoidance or congestion management can we do if it's in a private data center? Things like red or weighted red to kind of drop traffic to prevent TCP congestion, those types of things. We can do a lot more QoS and other things in our private data center, our private cloud than the public cloud. We want to be really looking at temperature and humidity. This is going to be really important. Systems get too hot, they either burn up or they slow them down themselves or throttle them down. If it gets too dry, we risk a fire. We get too much humidity, we damage the server. So it's always about managing that and trying to make sure that everything is just right. Now, there are standards for keeping data centers or private clouds to a certain, they're created from the American Society of Heating, Refrigerating, and Air Conditioning, ASHAR. And their metrics are that data centers should be kept between 64 degrees to 81 degrees Fahrenheit or 18 to 27 degrees Celsius. They typically like a dew point of between 15 and 59 degrees Fahrenheit or -9 to 15 degrees Celsius, a relative humidity of approximately 60%. And they provide very detailed recommendations on things like power equipment, power supplies, battery backups. They will get into, in many cases, equipment-specific guidance you should be looking at. So you may have certain things that your manufacturers recommend certain things for ambient conditions. You want to be very familiar with those things as well. Let's talk about maintenance. So in order to ensure continual uptime, systems need to be maintained and need to be maintained correctly. Individual components, potentially on a schedule basis. There's lots of areas in maintenance. Everything from the server fans being blown out so that I don't have they're not clogged up by dust. But there's work that goes on to these systems. If a device is going to be in a maintenance mode, basically speaking, remove any kind of thing that on it so that it's not going to be affecting anything else along the way. If we're going to maintain a server or take down a server or add DRAM to the server, maybe we take the virtual machines on that server and move them to another server. Whatever we're doing, we're just trying to keep those systems upright and functional. So let's talk briefly about updates. So vendors themselves will provide updates, and potentially it's going to make sense to update these systems and patch these systems, assuming they provide a security benefit or some other benefit to the business. And anytime an organization does an update, they shouldn't just push it. It's not like your iPhone where it just pushes software to you and it's okay. In a business that's running thousands of applications, you don't know what's going to happen anytime a software is updated or patched. So all these patches have to be tested. There needs to be a formalized update process that's going to include documenting how the update was done, when it was done, and why it was done. We're going to need a vendor communication that's going on, details, date, the code or whatever number of the system must be. For example, when an equipment's going to expire or be justified. Monitoring the update through a change management process. Absolutely. So when we have systems that matter, we shouldn't just let anybody touch our systems. Everything's going to need to go through a change management process, because what's going to occur is somebody's going to make one change, and that change can impact 1,000 different systems. So Somebody's going to need to look at that from a very holistic perspective. The key stakeholders are going to have to get involved. They're going to have to make sure the systems meet the needs of the business. So lots of monitoring, lots of change management that's going to be part of any update. Anytime an update needs to occur, all parties are going to need to agree on it, on a time, what have you. Those systems devices will be maintained during that maintenance window. Whatever patches will be done, and then immediately they'll be turned on and they will be verified. Stakeholders across the organization will have to end up testing their systems and make sure that they're still working. And this will get repeated for every system that's actually maintained. So we have to validate that everything occurred. We have to notify people, confirm that the updates are occurred properly, and then it's go back to normal operations. So that is for an update. So upgrades are a little different. Upgrades are more when we move to, say, a new version. So we go from one software version like Windows 10 to Windows 11. That's more of an upgrade, where the update is when we patch or we add additional features. Now, if we want to do an upgrade, again, this is going to have to go through a process. It's going to have to be formalized first in governance. Then it's going to require a change management approach. The update will have to be evaluated, or the upgrade. Then the upgrade will have to be tested by the QA department to make sure it's going to work. Then after changes are made, we need to document all these elements and all the things that have been done. And that way people will know how to maintain it in the future. Now, organizations are also going to have to think about patch management. So an organization, an enterprise may have 100,000 users. They could be big like Amazon and have 1.5 million users, or moderately big like Microsoft with 250,000 users, or anywhere in between. So in these types of environments, you're going to have a lot of servers sitting around and a lot of software sitting around over time. And all that software will have some kind of vulnerability or bug that somebody probably didn't notice when they first made it. And over time, bugs and vulnerabilities will be developed, or new operating system features will come out, which will cause some vulnerability, or some new application will come out, and that application for some reason will affect another application on the same system. So that will mean a patch or an update will need to occur. So businesses have tools for these things. Normally, patches are going to be issued fairly quickly in response to a vulnerability. So if it's a significant vulnerability, that organization may need to test it quickly and push it out quickly. And there's some times where you might do an expedited test if it's very critical or very severe. Now understand, each patch provides an additional risk and challenge because we don't know what's going to happen when the patch is actually installed. Sometimes patches come out, they're a little rushed, and then they brick systems. So we always have to test things or whenever possible. But of course, we have to consider the risk. If it's such a major vulnerability that and likelihood of being attacked, well, then maybe we test it faster. But we have to think about it ahead of time and plan it whenever possible. Now, when do we do patches? So it's all about timing. It's all about timing. And what do I mean by that? So if we don't apply it for too long, we're almost negligent for ignoring things that we knew we should have fixed. But if we apply the patch too hastily and we brick our systems or take down the data center or cause a problem, we also have another challenge. So we have to, it's all about, finding that perfect balance. We have to evaluate when we're going to do it, consider all the risk versus rewards, the risks and benefits of immediate versus delayed. So it's like anything else. We architects or consultants, we have to evaluate all risk, determine all benefits, and figure out what's the best trade. But most businesses would do well to schedule regular patching intervals at a periodic time, prioritize which patches are actually deployed based on severity, and come up with a plan to deal with vendors who are periodically coming up with patches and a way to test them and a way to deploy them. Now, businesses can do automated patching. Think about this. You have your systems, they automatically patch. Well, this is very fast, right? And in these systems, it'll patch it. And if for something doesn't work, guess what they'll do? They'll actually alert you. So they're pretty good. Now, that's not without its risks either, because a machine puts it on. It may or may not work properly, and now you may have a problem. So there's the risks. Misapplied patches, inaccurate reports, those types of things. So let's talk about the manual approach. Well, now you've got a person, they're putting on a patch, they're going to check and see if it works, they're going to test it. So that's good, but it's relatively slow. Now we've got one person patching 2,000 systems. Chances are they may miss a few systems because they're just going to forget. And again, it's repetitive. The person gets bored, they make mistakes. So, that's not necessarily perfect either. From the manual perspective, from a decision making perspective, you have to decide whether it makes sense to do automated manual or manual based upon the organization's needs. Let's talk about when patches should be applied. So we may have some automated tools that will require agents to put things locally on each device, and that's something we can use. They put like a little agent in and it'll go check in with the server to make sure patches are there, and then it'll pull the patch at the right time. Unfortunately, if the agent is not running at the time the patches are going to be pulled, they may miss patches. It may make it a little complicated when you've got internal clocks that are on different time zones. So realistically speaking, that can get a little icky. For our servers on our network, it's easy. They're all synchronized on the same time zone as network time protocol. But what about our users? Now, on the cloud, virtualized instances that are generally speaking not active when they're patched. So we can have a system that will receive its patch only after it's booted. So we can basically boot it and patch it and have it come right back up, or it'll reboot. So this can cause a delay because let's say you've got a server. How frequently can you actually reboot that server in a production environment? Now, we talked about manual patching, which has its strengths and weaknesses. We talked about automated patching, which has its own strengths and weaknesses. So I think what we should think of is maybe the optimal technique, and again, it's going to be based on business needs. Realistically speaking, where we're coming from could be a combination between manual and automated, where we've got manual oversights for determining the patch applicability and testing it. And then maybe we use some automated tools to propagate it out. And if we're going to have any types of service level agreements, we definitely need to make sure we've got patching in the contract as well. I think now's a good time to take a break. See if anybody has questions along the time.
Okay, everybody. I hope you're having fun with what's coming up and what we've already covered as well. Let's take a look at our first question here. So from Cloudy, what is the best way for a SOC team to fine-tune false positive alerts without AI trend analysis? The best way is for you as an architect to get out of their way and don't touch anything that they're going to be touching. That's it's a corny architect joke, but in reality, that's what should be happening. What I would suggest to you here, Cloudy, is if you don't want to use AI to provide you with some type of analysis in regards to pattern recognition or some type of historical incident response or incidents analysis, then you have to perform those duties manually, which means you need to have a robust monitoring system. You want to be able to look at historical data and then refine your rule detections based on that historical data. You can also look at thresholds. If the thresholds that you have set for the alerts and how they're going to pop up are too sensitive or too stringent, you'll have to adjust those. And then what you can look into is kind of moving away from this idea of using static rules or signature-based rules or even these threshold type of rules. And what you want to look towards is more having a rule set that takes into account context. So that way that you have more granular control over how a particular alert is going to be ingested and then eventually also, what's the right word I'm looking here for? Displayed in your SIEM system. So that will be from that perspective. But again, this would have to go into eventually something where you're going to have to do some threat modeling to understand how your threat model is going to work so that you can avoid a lot of these false positives.
And before we get off of false positives, I want to talk about sensitivity versus specificity. And this is absolutely incredible. So I may have an engineer that wants to get rid of more false positives so they don't have to be bothered by them. That could be the worst thing they might ever do, or it could be the best thing. And I'll explain the difference between sensitivity and specificity. A sensitive test will do two things. If it's very sensitive, it will most likely catch the hacker in the hacking event, but it will also generate some false positives. But a specific test will definitely rule it in. And in medicine, we use sensitive tests to basically be a screener, and then a specific test to say, yes, you do have this or don't have this. So let's talk about when we go very specific, where we don't get false positives, then we miss a lot of things. So we may need a very sensitive test because we've got a very high security environment, and we may want our team to get hit all day long with logs that they can work for, because it's better to do that and have more employees, even if they're going to be bogged down than looking at these alerts all day, than it is to miss a big attack. So that specificity and sensitivity of the test are really going to be the people that are designing these systems. These architects are going to have to think very carefully about what are the risks, because there's implications either way of having alert fatigue. There's, if it's too positive, there's implications in terms of the amount of staffing you're going to need if you get too many alerts. But if you're not sensitive enough, you might miss things. And if you're in a high security environment, that may be a big no-no. Kind of hope that helps.
All right, let's take a look at our next question. From Cloudy, must all maintenance windows be driven by a change control? I'll let you answer that, Mike. I'm going to give Cloudy a brief example as to why I'm going to be agreeing with your answer to this.
So generally, anytime there's all or must, we're generally talking about something that's incorrect. Now, why do we generally, and in most cases, use change control for a maintenance window? Here's the reason. The reason is, let's say I've got Billy Bob, and Billy Bob wants to use my systems, and Billy Bob wants to make a change. Billy Bob puts an access list on a core router and blocks the interior gateway protocol, and immediately the entire thing actually comes to a crashing halt. Now, that's a problem. Or I've got Billy Bob who reboots the server. Now, when Billy Bob reboots the server at 2:37 in the morning, as it turned out, the data science team was actually running a math calculation for their trades that they were going to do the next day for the bank, and you just shut them down. So we really need to understand the big picture. Except for the architects, they can't afford to get too close to any type of technology because we're so big focused on the business and a little of everything. The rest of our teams, for the most part, focus on what's in front of them. The application developer writes the application, and in most cases, they have little knowledge of the CPU in their device and what it's doing because they understand applications. Our hardware engineers can look at that device and they can figure out what kind of CPU, what kind of GPU, what kind of DRAM, what kind of ASICs, what kind of FPGAs we need from a hardware perspective. And you know what they see? The hardware. And you know what they don't see is any software along the way. The network people may see the routers and the switches, but a good network person probably won't know anything about Linux, anything about Python. They're going to know routing protocols, and that's it. And we're going to have some security people that are going to be good at data loss. And the point is, when we've got a business and it's so fragmented, if we don't ask before we make changes, there's a good chance we actually hurt another part of the business. So generally speaking, we use change control before we just do stuff.
Yeah, and something also very important to keep in mind, Claudia, Mike alluded to it, that it's not just for your benefit to have change control in place. Again, being part of a professional IT team, regardless if you're going to be part of like the executive team, which general architects are going to be at the very top of that, or if you're going to be more towards the support side, the operations side, is that you all need to be on the same place. Something that a lot of people never ever address when it comes to change control, because it is very often associated with this notion that it's going to be my tier 1 or tier 2 team, or maybe my engineering team that has to be aware of these change controls. And that is not true. change controls are generally driven by a business use case.
Yep.
And I know that sounds so odd to some of you that may have been in some type of engineering or hands-on role, because you're generally just being given these change controls and told, make it happen. But when those come about, what you really would have to ask yourself, what happened? Why am I getting this change control? What is the reason behind
Yes.
it? And then from a security perspective, what about our audit? Eventually, we'll have to run audits to make adjustments to our security policies. Change control could be part of that audit trail that we're creating by having them. So, as you see, just a simple question like that has so many dependencies that we have to look at.
Yeah.
But from our perspective and how we're going to look at it from the CCSP, always think of it from a business case first, and then let it matriculate downwards. All right, let us take a look at our next question, please. And this is from Toyin. They're wondering, in regards to upgrading as an architect, is it okay to use green and blue environment setups for production hosting while applying upgrade to the blue first before the green? What is your take on this? Let me answer this one directly.
Okay.
Yes, that's what you should do. What you shouldn't do, Toyin, is use terms such as blue and green. Not many people are going to be familiar with what you're trying to tell them with that. If you want to use something a little bit more descriptive, like you can say blue would be more like your life environment or production environment. And then you can say with green, this is going to be more your shadow network or shadow systems, or perhaps like a staging or testing environment. I think that will be a better way of helping those that you're eventually going to have to communicate with, because as an architect, you'll be cross-departmental, have cross-departmental communication. And in that case, always keep in mind who you're talking to. But in this case, yes, you definitely can do. It's very good practice. And the nice thing about what you're actually proposing here, to have a staging or test environment and then being able to roll it into your life environment, is if something doesn't work or something goes wrong when you do the actual transition into the life environment, the beauty is you can just roll it back at that point, because you have set up and put thought into setting up two different environments.
And here's the thing, Toyin. First, as an architect, you're not going to use any environment. You're going to be building a plan that's going to be used by the development team. But whether the application architects think they should use a blue-green deployment or a canary deployment or other types of deployment models, that's going to be based upon the way the application is, and again, on the business needs. Blue-green deployment, where you send some traffic to one, and if it works, you send traffic to another, is great. But there's other forms of application deployment methodologies that also should be considered, because each one of them has its own strengths as well as its own weaknesses. But it is a very common methodology. It's a great methodology. It's just choosing the right methodology for the right architecture.
Yeah. And as a little context, and then we'll move on to the actual content, is what Toyin described there with having basically two environments in place. That's also become a trend when it comes to networking and security, because it gives us almost like a duplicate of our production environment that we can test things out and then we can roll them over. This is something very, very popular when it comes to software-defined networking, where we can integrate these type of solutions or environments. But again, this is going to be one of those aspects, and we want to make this clear. You as the architect might be part of the planning phase and the strategy in having that type of environment put into place. You will never ever be actually touching it, or unless maybe you're off hours tinkering with it, right? If that's kind of like your thing, you might tinker with it a little bit to get your hands dirty. But just keep that in mind. Aside from that, everybody, make sure you give us a hashtag CCSP. Let us know that you're wide awake, that you're enjoying the content. We definitely hope that we're providing you value with. And aside from that, Mike, I'll hand it back over to you. Let's get a little bit further in. And for those, just so you guys know as well, if you're going to be looking towards where we are in the actual, let's see, study guide, we're going to be picking up here on page 292 with change and configuration management.
All right, change and configuration management. So when we're dealing with a data center operator, and that could be a company by themselves, or it could be their cloud provider, operators have to maintain a fairly clear understanding of what's going on in their systems and their assets. So whether it's your data center or the cloud provider's data center, somebody has to keep an inventory of what hardware they have, what software they have, what whatever media storage media they have. They need to document the configurations they have, and this way, if you've got a system, and let's say it's got a text configuration to it, and you've got a backup of that configuration, you get a new one and you just pop the same text configuration and it's already ready to go. So we want to make sure we've got good configurations and configurations that we know are locked down. For example, if we had a router, there's lots of ways you could administer that router. Maybe we want to shut some of them down ahead of time before we deployed it. So we can come up with a stock configuration, a gold standard with regards to our configurations. And then after that, we can be in a better position. And then we can keep what we have and back up what we have. So there's typically two processes that are either going to occur. There's either going to be a change management request, or there's going to be a configuration management. And they're two separate things. With change management, is the business says, okay, we've got a new sales tool. The new sales tool is going to be put on the systems at 2:00 in the morning. Before we put this new sales tool on, is everybody aware that we're going to do this change? Does this change affect anybody in any other parts of the system? Is this the time of the day that the business will be doing the least amount of sales, so it has least impact on the business? When this thing is going to be deployed, the changes will be made to this access list, this firewall rule, this route configuration of this router on this specific subnet. And then people test it potentially in a mock-up lab, and they test it, and then they actually deploy it during the window, and then right afterwards it's done. Configuration management's a little different. That's going to be documenting, say, approved settings, for example. Maybe, which lines are going to be open, how the software is going to be figured, hardware, what have you. In many organizations, though, you'll see change management and configuration management kind of the same, but they really are separate. Let's talk about what a baseline is. So, generally speaking, in an environment, we're going to have a baseline level of security. The baseline level of security says that Red Hat Enterprise Linux is the standard operating system. All these patches will be applied. A golden build will have this service, this service, this service. All these unnecessary services are removed. This golden build will have a host-based firewall, host-based IDS, IPS system, and an anti-malware package that's up to these standards. That's a baseline. And every new system that gets built based upon that. So by incorporating security baselines, no matter what, anytime somebody wants to deploy a new system, it's already on a somewhat secure system. So it's ultimately those things are going to be there. So whenever there needs to be a change, there needs to be a stakeholder input. So business wants to make a change. That chain is going to affect the network team, the security team, the storage team, the server team, the Linux team, the whatever team. They all have to go think about it. Also, that application, if it's a sales application, how does that affect the sales executives? How does that affect the sales leadership? How does that sales application affect the accounting systems behind the scenes when they make that change? So that's why, as architects, we're constantly going to stakeholders and stakeholders and stakeholders and getting their frameworks and perspective. And that's why there's never an easy solution, because it's going to take all that time to figure it out. Because we mess any of these things up, we can literally speaking cost a company to go bankrupt and 80,000 people lose their job. It's that easy to do it. So we have to get this information. We've got to get a baseline. We've got to get the stakeholder input. We got to know what we're doing, why we're doing it, and when we're doing it. So when we start thinking about it, we have to think about what's going to be applicable? So can we create a baseline that'll work for 90% of the stuff that we have in our environment? Great. Now, what other baselines can we create for that other 10% of the stuff? Maybe we need 3 or 4 customized environments, but whatever. So we may need multiple baselines necessary for different departments. We may have 100 different baselines, but the point is, ideally, we have as little as we need to do the job. So let's all talk about some additional things we should do with baselines. We may have a golden build now and then new security vulnerabilities come out. So we're going to need a new golden build for the future. So we may have to continually update our baselines based upon dynamically changing market conditions. Now, there are going to be times where we need to deviate or have exceptions to the baselines. So first, we want to regularly test our baselines and make sure that they're still good. But we may have an accidental, or we may have an intentional or unintentional deviation. So I might need to have something that's very different for a specific application, in which case I'll go through and approve it if it's appropriate. I can also have somebody doing it by accident, or I can have a malicious employee that's trying to come up with a backdoor into the system. It can be a lot of different variables. So when we've got deviations, whenever possible, we want to fully patch whatever systems are necessary, find these rogue devices, maybe shut them off, block them until we figure out what they are, figure out if these rogue devices or these weaknesses have been used by hackers. We have to figure out what kind of weird versions we have, but the whole point here is we got to find out why we have a deviation and we want to go fix it. Now, it's going to be the responsibility of the people that are involved in change management decisions and in change management roles. They have to determine if a deviation is okay and what follow-up needs to occur. Is it a deviation from configuration management? Is it a deviation from a security thing? But whatever the case is, we have to come up with it. And with regards to baseline, we want to use it as an optimal place, but it's not going to be an absolute. Because nothing in technology, nothing in medicine, nothing in science is ever going to be absolute. So we may come up with a rule, but we're going to have a lot of exceptions to any rules that we actually make. So let's talk about exception requests or deviations from the baseline and when they occur. We need to expect numerous requests for expectations for specific users, offices, projects. We need to make sure that our baselines are highly flexible and practical at the same time. And there are times when we need an exception and we need to think about it and how do we deal with that exception. So it's better to actually create an exception to a baseline in many cases than it is to come up with a convoluted workaround. That can be things that are pretty rough. So let's talk about some change management processes and formalize them. So when we architects actually create a governance structure for our organizations, one of the things that we actually do is create a change management environment. And we have to create a change management board. And the change management board or change control board will have a process to evaluate everything. And typically speaking, you're going to have stakeholders from various divisions, both in the business and the technology divisions. And anytime you want to make a change, everyone will inspect the impact of their change on either their business unit or their technology unit or what have you. And then they'll approve it or not approve it. So when there is a chance to do a change that needs to be documented. So there should be a process for exceptions. There should be a process for normally doing it. There should be procedures for addressing deviations. And there needs to be enforcement measures if things are done wrong too, because we can't just let our systems to run amok and have all kinds of problems. So we need to make sure that our change management board has a representation from a lot of stakeholders. If we want to make a change and our change management board is the networking team, and I'm real comfortable with the networking team because it's where I come from, but we make a change, it might affect an application. It might affect a business division. So we can't have it of just networking people. You need to have it from a wide variety of departments throughout our organization. So the change management board will review change and exception requests. They will determine the impact of the change. They're going to be doing an impact analysis, as will the architects, on the functionality, productivity, and the security of the change and what it's going to do. For certain changes, we'll need to assess funding. We may need to train certain people as part of our team. We may need to implement new security controls. We may need to bring in additional staffing for these changes. And when we're going to make changes, we need to make sure this team meets regularly. We don't want to have big delays. And we'll also have to determine how often do these change control meetings, because we could have them done every day, but now you're taking your stakeholders out of work. So we have to find that balance between productivity and still speed and agility to deploy changes when they actually need to occur. Some organizations are going to be small enough and make changes fairly infrequently, where they may meet on an ad hoc basis. Okay, Mike and Nick want to make a change, so let's go evaluate this change. Other companies are going to need regular meetings because they're going to be constantly dynamic. They're going to have a lot of moving parts in their business. So let's talk about change management forms. So usually there's a process. Somebody typically fills out a form. But realistically speaking, before anything occurs, we need to have an asset inventory and understand all assets that we actually have. Good news, we did a business impact analysis to determine what we can handle, maximum tolerable downtime, RDO, RPO, cost of our security breaches. We've got all this information. So we should have that. We should figure out by going from a baseline or making a change or deviation, what is the impact to the business? What is the impact to the technology? What are the risks? What are the rewards? Do the risks outweigh the rewards of the change? And maybe if it's related to the baseline, for example, that's changing, after we get approval, we create a new baseline and store a new version of the baseline. So let's talk about normal operations and normal meetings in a change management board. There's going to be normal meetings to review and analyze change and exception requests, maybe authorize or disallow a new request. We're also going to have change management meetings for testing. So there may be tests that we authorize in an isolated environment or a sandbox, if you will. There'll be change management meetings as it pertains to things being deployed. Okay, we've tested something, we want to add it, we want to deploy it. What are all those things? And there'll be meetings related to that. And we're going to have to document everything as we go through these change control processes. I'm going to briefly talk about release and deployment management. So realistically speaking, we need a process for this too that's going to be supported by change management. So a software engineering process is really about arranging all the elements needed to deploy new software and successfully, repeatably, and in an effective manner moving forward. So typically speaking, when it comes to release and deployment management, we have to scope it. We have to plan when it's going to occur or schedule when it's going to occur, and of course, deploy it at the appropriate time. There needs to be some kind of coverage of every single environment for release and deployment management, whether it's being developed, whether it's being tested in QA, whether it's being staged, all the way to the production environment. It needs to be scoped and in scope. And this process, realistically speaking, for release and deployment management really should cover the entire pipeline. From the time the business will give you the story of what they need to the time it's coded, tested, and produced. Now, when we think about release and deployment management, we always have to think about growth. So growth and things have changed over time, We may be looking for means like Agile to develop software more quickly. But we're always looking for ways that we can kind of release, keep track, increase the velocity of what we're doing. Now, when it comes to the recent deployment management, there's a little bit about that I'll talk about DevOps security. Don't think DevOps as security by any stretch of the imagination, even DevSecOps. It's just integrating a little bit of security into the DevOps process. So as we've got more DevOps-oriented environments, And we've got these cross-functional DevOps teams that allow for more predictable software and and faster software releases by bringing down some of the barriers between the software developers and the operations people. We've got this tight collaboration, so it's going to streamline software development. DevOps security is integrating security into this pipeline. So if we're going to have more frequent software releases, we're probably going to have more frequent software vulnerabilities and bugs. So agile development, get your code out, use DevOps, faster code, generally means less QA testing and bigger security risks. So we need to make sure that we've got some automated and some security at every step along the way. So if there's a CI/CD pipeline going on, to shorten this software delivery, make sure we test the code along the way. And here the key, we're trying to optimize the velocity of software deployment so the business can get what they need faster, deploying new things faster, and at the same time making sure that new code that's being released doesn't introduce new software bugs or new software vulnerabilities. Now with DevOps, we can add some security automation, some administrative and technical controls. Administrative controls could be things like a verifiable set of requirements and approvals for new software to ensure that a process is followed, maybe a peer review of the code. We can also put some technical controls on DevOps to improve the security. We can do static code analysis and vulnerability scans on the versions of new code in the staging environment. So we can do lots of things along the way. Regarding problem and incident management. So in IT, disruptions are inevitable. Put all your eggs in a single cloud provider and use 2 availability zones in 2 different regions each, or 3 different regions, and the cloud will go down. And no matter what you do, you just can't plan around that unless you plan around using a separate cloud. Well, even if you use 2 clouds, if an electromagnetic pulse occurs, it could potentially affect 2 different clouds. So along the line, there's always going to be some disruption in IT. And it's from the architect perspective, it's about how to plan it. From the engineering perspective and the operations perspective, it's what to do when it actually happens. So we have to plan for problems. And we have to plan for what we do when these things actually occur. So an incident's going to be anything that causes a disruption. A problem is going to be a potential cause of an incident. And every incident is going to begin with a problem. But not every problem leads to an incident. I'll explain the difference. We could have a vulnerable firewall. That's our problem. And somebody hacks in and we've got a security incident. That's an incident. We could have a problem on one of our servers, but nothing happens. It's maintaining up and it's not attacked. It's still operational. So that means it's not an incident. When it comes to problem management, we can think about technologies, processes, and procedures to reduce the impact of an incident. Okay, if you're on AWS, and AWS is a great cloud, you can reduce your likelihood of an incident at AWS by load sharing with Azure and putting 50% in each cloud. By the way, it doesn't cost you more to put half here and half here than it does 100% here for the most part. It's almost the same. It's just where you're spending your money, spending it all in one provider versus 2 providers, plus or minus a few percent. Now, incident management is going to be different. Incident management is what happens when something actually occurs. So we've got 2 kinds of management. So there's lots of ways we can do IT service management and continual service improvement. There's lots of libraries, best practices, and frameworks on how to do it. ITIL has theirs, the Information Technology and Infrastructure Library. They have their own practices for designing, maintaining, and improving IT services. They're applicable to pretty much any IT function, whether it be email collaboration, customer-faced applications, cloud migration, and they're fine to use. We've got the ISO standards that are there. The ISO, I think it's 20,000-1 is a pretty common one, and that defines your operational controls and your standards for managing IT environments. It's fairly similar to that ISO 27001, but that's more related to information security management systems. but they typically support ITSM with processes, procedures, and it's comparable to looking at the ITL framework or the COBIT framework. There's lots of frameworks we can use, and they all pretty much do the same thing. The key goals of IT service management are to identify and find the users and their needs, to design IT services to meet those needs, to successfully deploy these services, and to enter a cycle of, we have a need, we do something, we evaluate it, improve it, and we're constantly getting better. And that's really the key of service management. Continual improvement. So we constantly need to be evaluating which services we have and then figuring out what business value they actually provide. And again, it's a constant cycle. So we need to think of areas, key areas where we can constantly improve our services in cloud. If we're choosing a cloud service model like software as a service, is that the best thing that we're using? Should we be using infrastructure as a service? What's going to be better for us? What's our workforce look like? Do we have a very mobile workforce? And how does that impact our remote access design? We've got lots of options, and each one has their own strengths and weaknesses. The key thing is that we need to provide access for the most part for our users wherever they need to be in order to perform the daily operation of their jobs. So we should always look at compliance needs when we're dealing with any type of service we're actually creating, and what's necessary to meet any kind of industry or regulatory or governmental environment. And in many cases, we're going to have systems. For example, we may have a hospital that's in the US, so they're governed by the insurance companies. They're also governed by HIPAA privacy regulations, but that hospital might still be being regulated by the Joint Commission for Accreditation of Hospital Organizations. And there'll be other organizations involved too that they're actually dealing with. So we may have a lot of compliance issues that we actually have to deal with in certain places to think about. One of the things we should think about long time is cost, time, and resource savings. So when we look at the cloud, is it going to be cheaper for us? Is it going to be better for us? What are we trying to achieve? If we went to the cloud because it's cheaper and we find out it's more expensive, then we should leave that cloud as fast as we got on it, assuming we didn't design our architecture improperly. If we went to the cloud for agility because we know that that business is going to be deploying new things and coming up with new solutions, and they're paying 2.5 times for the cloud, they're okay with paying 2.5 times for the cloud because they value that agility and it's helpful to them. So what are we doing? Are we getting where we're at? So we're constantly looking to measure the results of what we've done. So let's look at some metrics for continual service improvement. We need to identify what's working well, what's not working well, what we can do to change it. We need to measure the effectiveness of those changes. So what if a business can tolerate 5 minutes of downtime, but it now has 30 minutes of downtime? Well, chances are they're going to have to either improve their architecture or they're going to have to input some kind of change control process. I think now is a good time to take a break and answer some questions before we get onto a new topic.
Good timing. All righty. Let's take a look at a few questions we noticed popped up in the chat box. From Say, again, I apologize if I'm mispronouncing the names. It says, I believe it's SEI or SEI. It says, change in configuration management is deep into service management. In fact, we have been covering ITIL processes for some time now, and they love it. Correct. And you notice also that there is some mentioning of these different standards, right? The ISO, the 27000 and 27001, and then as well as the ITIL change management process. So they're all kind of interwoven. The biggest thing here is going to be how far we eventually get involved at it, especially from a security perspective. But in essence, very good information. And thank you for sharing that wonderful statement.
Thank you.
All right, let's take a look at our next question here from, I believe it was Cloudy, right? Cloudy, yeah. So whose job is it to write and outline the steps that are included in change management. Mike kind of broke it down a little bit when he described to you that there's going to be basically like governance teams or change management teams or boards that are going to be put together. And what's going to happen is they're going to be including people from different walks of life. So you might have an IT manager, you might have the security officers. That could be actually yourself or your CISO from that perspective. You could also have, believe it or not, I've seen this happen. You might even have project managers involved in this stage that help kind of outline the processes and then kind of put together. So it's really a collaborative process of outlining the documents and then the steps that are going to be needed so that you have effective change management processes.
Yeah, and let's talk about the difference between a new architecture versus a change management for a second. Change management, and I'm going to pick networking, for example. Change management is going to be, I want to update the operating system on a router. I want to redistribute a route on a router. That's change management. The new architecture is, okay, Mike, we want to deploy IP multicast video across the organization. So now I need to meet with the executives. I need to figure out what kind of video they're trying to send it, where they need to send it, the user distribution of the video, and the timings they need to get through that video. And then I can evaluate whether it's unicast video, multicast video, and then I can determine whether, after evaluating that, we're going to use something like PIM sparse mode, PIM dense mode, DVMRP, PIM sparse dense mode. What are we using to figure out where the stream is coming from? Is it going to be an unknown stream where we use IGMP version 2? Do we know where the stream is coming from, the source address where we can use source-specific multicast and IP IGMP v3? That's a new architecture. So now I got this new video project. I've got to go find from the stakeholders. I got to design a new architecture. I got to evaluate the business processes, how it'll be used, look at the current tech, future tech. That's new architecture. But making a small change, that's typically change management. If the change turns into a big change, it's a new architecture, and it kicks off a new architecture cycle. Hope that helps.
All right. Great information. Okay, let's take a look at another question, please. And this is going to be from Cloudy as well. It says, when all the teams join to review a change, is that what they call a change? I believe you referring to a change advisory board. The names are interchangeable. There could be change advisory board. As it was mentioned by the CCSP, you might have that it's the change management board. There's different names assigned on it depending on the organization. But generally, yes, that's what we will be calling. And again, you'll have different people from different departments that are going to join these type of calls so that you can make sure that you can evaluate and document, of course, anything that you might find from how is it going to impact, how's the change going to impact the environment and the organization, what are the risks, and of course, something very important, what are the benefits of actually following through and applying some of these changes or policies. So those are also very important things. We don't talk about a lot, and many times we think change and whatever the outcome we don't discuss, but we want to look for the benefits of something because there's no point in changing anything or making adjustments if it's not for the benefit of the organization.
Yeah, and I really encourage you not to use acronyms. They cause all kinds of fusion. To me, CAB means circulation, airway, and then breathing. And it could literally mean anything. It could also mean a yellow car that I get into. So I can give you 10 different things, all in tech, that are all from the same name with the same abbreviation, and they all mean different things. So just a guidance as you move in your career, it'll help you avoid some serious mistakes along the way where people misconfuse you. And I've seen it happen all the time.
Yeah. And I'm going to give you a very practical application of always spelling out your acronyms. It's going to make you be more relatable. It's going to make you easier to talk to. And guess what? Your not your change, you see, now I'm stuck on change management. Your stakeholders are going to love you. Your managers, they will love you because you're speaking more concise and speaking their language. So keep that in mind. It always helps. From SR, after cloud control assessments and analysis using risk management framework, what is the processes to achieve an authority to operate? SR, we'll cover that a little bit later. We'll have an entire different section when we talk about risk compliance, where we're going to be discussing that a little bit more. I'll also going to refer you, and I'll provide it in the link. The NIST has a wonderful risk management framework, which is fantastic to keep in mind. And I'll provide you with that link in a little bit in the actual chat, so that you have something to reference from.
Yes. But remember, the process is going to be based upon the needs of the business, and every business is going to require different processes. So we can't solve it now. If we try to solve it now, we will cause chaos and damage to our business. We need to understand it first. So can never have a solution without understanding what we're trying to do. I hope that helps. I can always tell, SR, I bet you've been an engineer for a long period of time because you're looking for that exact process and methodology. Let me know if you've been an engineer for a long period of time. Because in architecture, it's all about opening the mind to see all the potential possibilities first. And engineering, it's that deep focus on what's directly in front of you.
Definitely. Go ahead, Chris. Pull up whatever statement or question you had, unless it was. Let me take a look.
Oh, wasn't Chris said
okay,
it wasn't
that wasn't a question. Okay, yeah. And again, for everybody, as you get more comfortable with changing your mindset and how you should be actually thinking, or what your thinking process should be, these things become a lot easier. One of the things that I always tell people is, it's a mile wide, an inch deep. That's what when you want to stay first. It is only when you have specific things to accomplish, that's where you want to dig deep into your reference material. That's where you really want to get the hands on. Aside from that, always keep your mind clear. Take almost like a backseat to these things. Mike, on some of our Q&As, he'll show a picture that is zoomed in onto a squirrel. The squirrel is sitting there enjoying itself. And when you zoom out, you see our beautiful little chief feline officer, Cindy, standing in the background and just waiting for the right time to introduce herself to her squirrel friend. So keep that in mind. Aside from that, if you've been following along, we're going to pick up in a minute or so on page 308 from our study guide. But in the meantime, again, if you really like the video, give us a hashtag CCSP with the content as well. And I always want to call back to this because this is very important. This is a free service that we offer. It's going to be our Q&A that we're going to have tomorrow after the bootcamp. So it's going to be a couple of minutes after 5 p.m. Eastern Standard Time. That's where we're going to have about an hour or two, depending, see how we're going to do our Q&A session. And then on Thursday, that's really your opportunity to shine and ask these career questions, where we'll have a webinar on Zoom, just like the Q&A, where you can ask your career questions, and especially tailor towards if you want to gain your first cloud architect job. And of course, you can ask questions in regards to network architecture, security architecture, things that you're looking for to have some clarity on how to be able to approach. And Mike does a fantastic job in also laying out the particular, and there's quite a few, but skill sets, both technical and non-technical, that really will aid you in becoming a rock star architect, irregardless of what domain you happen to pick. But with that said, Mike, I'm going to hand it back over to you, and let's take a look at business continuity and disaster recovery.
My kind of favorite stuff. We start getting back to the business, which is what we all know that I love. So, well, of course, I still love networking, but that's neither here nor there. I'm business focused. So when we talk about business continuity and disaster recovery planning, and we've introduced the concepts earlier, what we're really dealing with is what's going to happen for the business if a disaster were to occur. How do we keep that business up and operational? So business continuity is about keeping the business up and operational during a service disruption. So a couple of months ago, or maybe it was this year, all of a sudden, there was a problem at United Healthcare. It had a hacking event. And while they were dealing with challenges in their software, people couldn't go to their doctor's offices, hospitals couldn't bill for procedures, so they stopped doing procedures. Now, the hospital still needed to stay up and operational in case somebody was in an emergency, because the emergency department will take care for you regardless of your ability to pay. And people in the hospital, regardless of whether you can bill their insurance, you can't let them die on you. You still need to do something. So even under critical circumstances, emergencies and critical things still need to occur. You've got a 911 system or a 999 system in the UK, or an emergency call system, and the systems are down. Well, maybe you got a jury rig, some kind of service or something that you can actually do in there. So Business continuity is keeping that business going regardless of whether there's a problem. Maybe having paper checklists or something. I don't know. Depends on the business. Disaster recovery is a little different, and that's resuming operations after something happened like a disaster, like a hurricane. So a disaster is anything that's going on longer than 3 days. And we've seen lots of examples of this year, especially in the US. We've seen whole cities that have been underwater that have caused lots of challenges. We also have parts of Florida that got hit by a couple of hurricanes this year that also were struggling and had days without power. This is kind of the thing that we're typically talking about. A disaster can be called, and in case you see it on the exam, it's a Greek word. Anthropo in Greece means person. So you may hear the term called anthropogenic. Now, genic means create. Anthropogenic means created by a person. You may hear that. So the people can create a disaster. It could be a natural disaster like an earthquake. It could be an internal disaster like a fire. It could be an accidental disaster, a malicious disaster where someone wants to hurt you. The key is, how do you keep this business going and resume operations and function after the disaster? The first thing that's part of a disaster recovery plan is prioritizing safety. So you have to make sure that the people are safe. Are the customers safe? Are the employees safe? That's priority number one. Nothing is prioritized higher than the people that work there. Now, we also need to make sure that if we have to activate something, that the key members know about it. So how do we deal with it? I live in Florida. I am not joking. I get emails from the governor of Florida all the time. Emergency weather coming in. Make sure you actually have this. Emergency coming in. Mike, are you prepared to volunteer as one of the medical professionals here? State of emergency. Mike, you can give new prescription refills early to your patients. I get it every time there's a storm. Now, think about that. You've got a business. All of the employees, the key partners, potential customers may need to be notified. So how do you do that? Do you have a phone call tree where I call one person and that person's responsible for calling 2 people, and those 2 people are responsible for calling 10 people each, and those 10 people are responsible for calling 100 people each, or what have you? They dial all day, but they need to figure that out. Maybe there's an SMS blast. Maybe you post it on your website, but what's going to work for your needs? Now, who are you posting this to? It could be anybody. It could be the regulatory environment. It could be the public environment. It could be your people. It could be your customers. Now, when we have a disaster and we have to do an evacuation, it's all about the egress or getting people out of the building. So that's why you want to make sure that there's no obstructions in the hallways, no delays in evacuation. Emergency path doors should open from the inside out. They should be something that you can secure from the outside, but you can always open from the inside. We need to make sure that if we've got escape path, they've got lighting that kicks in, potentially on batteries or backup generators. We may need sprinkler systems along the way to actually protect against fire, and that should not be restricted. We may have some non-fire water suppression systems, and they need additional controls. There are some systems like Halon that suck all the oxygen out of the air. We can't deploy them in a room with the people in them. But when that last person leaves, we can push a button and they can spray all these gases that would be potentially toxic to people, but can put out the fire and protect our servers so they don't burn, because they have no fuel to combust, no oxygen. Now, there's always things we can think of. So our environment, the physical environment, the architecture of the physical environment, maybe it needs to be built a specific way. When I go to my house in New Jersey, you know how they made it? They use wood. They have little wood things. They put plywood and they put aluminum siding on it, and it's good. Where I live in Florida, the houses are made out of cinder blocks. And they put little steel rods in the cinder blocks, and they fill those cinder blocks with cement. And that way, if we get a 150-mile-an-hour wind with a hurricane, the house doesn't care. So we have to be thinking about where we're doing and what kind of building materials we might need, fireproof doors, whether we're in an environment where we need to withstand tornadoes, whether we need to withstand flooding, how we sell. We got to plan all of that. And we need to make sure that all of our buildings and facilities can actually tolerate whatever environmental hazards actually occur. So after we prioritized and focused on safety, the next thing that we need to do is determine what our critical operations are and what we need to do to get them back. Now, how do we know our biggest, most critical operations? How do we know what we need to do first? Remember, we did a business impact analysis in the beginning, and we identified assets with the greatest risk if they're compromised, and the key most important things inside of our organization. Now, in keeping things going, from an operations perspective, the main focus in the cloud is going to be their data center. So we need to be focused on connectivity and being able to get there. The data center, if it's ours, they need to make sure they have focus on power, cooling, whatever they need to, connectivity, utilities, all that stuff may need to be working. We need to understand what those critical assets are, which we talked about creating an inventory much earlier, but we need to know what they are so we know what we'll need in the future. We need a good governance policy. So we should set up plans that are going to be derived from the organization structure. Policy should define roles, who does what, terms, enforcement of the policy, how the disaster recovery plan will be executed as such. It'll describe all descriptions and characteristics in the disaster recovery business continuity plan. It should be straightforward. It should say, if this occurs, you should do X, Y, and Z stuff along the way so that people don't have to try to figure out during the course of an emergency. Additional details can be included in appendices or attachments of those kinds of things. One element of the plan, as we talked about, is an asset inventory of everything, hardware, software, media, versions, in case you've got to rebuild it again. We have to have a criteria of what is actually a disaster. So who differentiates and determines it's a disaster? And we need to think about what do we do in a disaster versus normal times. And we have to differentiate the risks of operating in a disaster versus traditional. And in our plan, we want to balance the needs of either overreacting versus underreacting. So we have to be able to figure out, how do we declare a disaster? What is the process for disaster declaration? So we typically have to delegate an authority, either an individual or an office of the CEO or the COO, what have you. We typically have to come up as part of this plan as who are the key essential points of contact that we need to work with along the way. What are their responsibilities? Are we dealing with own internal resources? Do we have other vendors we're working with from this disaster recovery perspective? Do we need to talk to regulators? Do we need to talk to law enforcement? We've got to have a plan for all of this. Because in general, in an emergency, we're probably going to need to deal with a lot of them. This plan should be detailed with tasks and actions of what needs to be done. Maybe we have checklists that outline a specific action or an order of execution or things that need to occur. Because checklists will help keep untrained personnel performing well. Now, in our policy, we really should split detailed elements into various attachments or appendices. So certain things are going to have to be very detailed, and we want to make sure that they're separated out and easy to find. The main policy should include an explanation and a rationale for what is in it. It should include enforcement activities and any regulatory investigation. So we've got a bank. The bank's been compromised. Do they need to notate the SEC? Do they need to notify the Secret Service if, for example, identity theft or any type of currency schemes were going on that they noticed along the way? All this kind of stuff, who would they need to know? Do they need to notice another regulator? Do they need to, who's going to talk to the press? Which people address what? All that's going to be in there. We really want to create this business continuity disaster recovery toolkit. And We want to make sure we put it in a secure environment, maybe a secure container that's fireproof, waterproof, I don't know, what have you. It's got to be durable. We should have hard copies of it in printed form so we can refer to them in an emergency over a piece of paper in case we lose power or we lose our technology. What good is a plan that requires your technology to work if your technology is not working? Generally speaking, we should have a duplicate kit. When it comes to high availability, there's a saying, 1 is none, and 2 is 1, and 3 is greater than 2. You may also hear it called 2 is 1 and 1 is none. Well, here's the thing. If we've got one hard copy in this location, chances are we should have a second copy of the disaster recovery plan, just in case one of them gets lost or was stolen or not replaced, or who knows. The plan should have, the document should have a current copy of the plan with all dependencies and the key agendas. There should be emergency and backup communication listed inside of this plan. The network and infrastructure diagram should be included in this plan so we know what the environment looks like. Software for rebuilding critical systems, including updates, patches, it should all be documented. We should have good, strong emergency contact information in this plan and a notification list. We should have tools that we can write things down with, like pens and paper, and pens that can write in potentially a wet environment. We need to have emergency equipment. Emergency equipment might include chem lights. It might include flashlights. It may include potable water. It may include food rations or MREs or something that can be there that are durable. We typically need to have batteries to operate equipment if and when emergencies occur. And these kits should be regulatory checked, packed, maintained, first aid kits, what have you. Bear with me a second. So the last thing I want to address today, and then I'll take some questions, is something called relocation. Sometimes in our disaster recovery plan, we're going to have some relocation considerations. So HR and finance obviously have to be involved in something like this. We may need to relocate various departments or family members to remote areas or have them working in hotels where they've got access to a shared data center or something, or a co-working space. So we have to think about the cost of relocation, the challenges associated with relocation, and are they practical, and do they make sense for our organizations? I think I'm going to take it to there. That gives us 10 minutes of questions to end the day, and we'll take it from there.
All right. I actually don't believe we have any new questions here. But what we'll do, everybody, this is just a common courtesy. Sometimes instead of eating up more time than necessarily, we'll give you some time back in the day. But I do want to make sure to let everybody know is make sure you come back tomorrow at 2 p.m. Eastern Standard Times. We have a lot more to go through. We're going to cover the rest of the section when it comes to key business continuity concepts. And then eventually we'll get into what everybody's been kind of already trying to jab at since the beginning of this bootcamp last week on Monday, is the legal and compliance issues. So this is where we can go a little bit more in detail in regards to what is necessary from there, and maybe cover some of the actual standards and guidelines that are in place that you should keep in mind as a security architect, regardless if you're going to be on premises, meaning on site, or if you're going to be a cloud security type of architect. Aside from that, I want to make everybody aware again, because this is really something dear to our heart. If you are interested or know somebody that is looking towards becoming or gaining their first architect job, Thursday's session that we're going to have on Zoom is going to be your bread and butter, or their bread and butter there. You're going to be able to come off mute. The wonderful thing is, if you have a camera, we can do what architects do best. We can have a conversation face to face and go through some of the things perhaps that you're interested in, finding out what type of roadmap could I potentially need that could get me towards my goal. Because what we often find is that it's very difficult to hit a target that you're not understanding what it is to begin with or what general direction that you need to go. So that's going to be a wonderful opportunity for everybody to engage. And then, of course, tomorrow, a little bit after the bootcamp, we'll probably say 5 or 10 minutes after the bootcamp, we'll have the link also in the chat box when it comes to our Q&A session. Make sure you attend it. This is going to be more career orientated, but if you do have any additional questions in regards to what was covered or just in general some career questions, feel free to answer them as well. Aside from that, we are the gift that keeps on giving. We got fantastic resources down in the description box, everything from a CCNA bootcamp if you want to get up your networking knowledge a little bit further. And we also have a cloud bootcamp that had to do with, more specifically, the Amazon variety of cloud service providers. In either way, it is fantastic content, gives you hours upon hours of free content that you can enjoy as well. Any closing remarks, Mike? Anything that I've forgotten to mention besides we had a lot of fun today and you did an excellent job?
Yeah, thank you for that, Mark. I always have fun. I love talking about these things, and I love security. For me, I always started out in that environment where everything I had to do required a lot of security, it required a lot of availability, and required performance. So for me, I love talking about all these things. I also love careers. Like I said, like Mark said yesterday, there's a critical shortage of 4.7 million security people. Same thing with cloud architects, same thing with enterprise architects, same things with AI architects. Companies can't find them. I mean, there's a lot of people that got certifications, but they can't work. They don't know anything about architecture, and the companies are dying trying to find them. Same thing with security people. There's incredible opportunities. The opportunity is there for those that know what the employers are looking for, and that's what we're going to do tomorrow night. We know what employers want. We've spoken to so many of them, so we can tell you and prepare you with the stuff that's going to get you hired, as opposed to the stuff that you think will get you hired. Because unless you've hired people and unless you've actually worked in the field, you often don't know. So tomorrow night's going to be about all kinds of careers. I know I have my preference for architecture careers for lots of reasons: higher salaries, the way you're treated, and the upward mobility. But I got to tell you, I really love people in more technical careers like engineering careers as well, and they're a very critical part of the team. And there's ways to boost an engineering career too. And it's not what most people usually do. And it's those things that engineers can do. They can take them from their base engineering job and put them into a distinguished engineering position that earns hundreds of thousands of dollars a year more. And you want some of those secrets? You ask how to earn more tomorrow night. You talk about the things that get employers to notice. You get ahead. I don't care. We'll talk about them. We just want to help you when it's live on Zoom. So bring your questions. On Thursday, join us on that How to Become an Architect, where we go over the role. We'll literally talk about what we do. We'll talk about the skills you need and why you need them. And then from there, you'll know exactly what you need to learn. You can either learn with us or you can go get an MBA or do whatever you want, but you will know exactly what you need to learn. And that way you're going to have a great career. Thank you all. Give me a hashtag CCSP. If you enjoyed it, give the video a like, subscribe to our channel, hit the bell to be notified, and we'll see you at 2 p.m. tomorrow, and we'll get to more CCSP material. Thank you, everyone.
All right. Enjoy the rest of your day, morning,